We've even got producers picking different cameras and things like that. It should be. I'm quite excited to see it all go, actually. I've even got a virtual laser pointer if I point things on the screen, so it should be really quite exciting. One thing I can't see is how many people are logged in, because we're streaming in 4 different places. Both hello to Facebook Live people, I think we just got that one going, and on YouTube, and then Twitch channels as well. Hello if anybody's coming from Danny's Paleontologizing Twitch page. I think Danny's really made a great community there. It's something we talked about many years ago, about that kind of a page, that kind of a thing. These sort of people who really like fossils, or it's a really interesting subject, and I think that we could be much more accessible to the public by doing more things like that. And I think Danny's made a really good job of it. And long may it continue and grow and become all kinds of things, as it is doing, of course. I was going to say something else. I'm just kind of ad-libbing before my slides come on. So, yep. This is the first time we tried all these different channels. Steve has been, if you're on Steve's Twitch stream, that's been growing, doing really well. Steve doing his ASMR live streaming of fossil preparation. That's another Twitch stream you can watch. So Steve is our preparator. You'll see him in person later on. And he'll be showing you around the lab. And we're thinking of doing more live streams of fossil preparation, specimens, that kind of thing, from the lab in the future. And I've got a few ideas for different things that I would stream as well, which I'll talk about a little bit, probably during this presentation, but also during the afterwards. So I think we're 6 o'clock on the dot. I think we'll give it a minute or so, or 2 minutes, maybe a little bit longer, just to see if anybody's clocking in. Again, I have no idea how many people might be there.
5 so far. Just keep welcoming people.
Yeah, we don't usually get too many people to the live stream, but one of the cool things about this stream is that it shows all year round on our local TV network. So we actually get quite a few people stopping us in the street and saying they saw us on television in a good way, which is quite nice, and also shows what we're doing here at the museum locally. Obviously, with the web streaming, we can reach a global audience if that's of interest. And I think so many of these fossils that we've got, they really are world-class fossils, and we don't have enough time to show everything that we collect in a year, and I'd have to photograph them all, but there's so many fabulous things that we'll pull out at the end. And obviously if people come by and visit the museum, they can see some of these things in person. So let's see how many minutes we're at. 2 minutes in, maybe we'll give it another minute or so, and then we'll start.
We've got a big group of people here ready to hear the presentation.
Oh, do you want me to start?
Yeah, and then across the 3 different platforms, we've got
55.
Okay, well, maybe we'll make a start then. So I assume I can just click the buttons on here and it moves. Yeah. Excellent. So, welcome to the 9th annual field report. This is about the 5th one I think we've ever done live and streamable on the web. And if you really want to, you can go back and see all our previous years' ones on our web page. But anyway, we're approaching that 10-year point. And I really thought this was a good way to show what we've collected through the year and some of the things going on at Badlands Dinosaur Museum here in Dickinson, North Dakota. We do have what's probably the biggest field operation in the northern Great Plains region. We spend 3 months every year digging. So let's take a look. So a little outline as to how this is going to go. Talk a little bit about what's going on in the museum. Then we talk about new fieldwork finds. It usually takes about 45 minutes. And then we go into what I call our live section, although this is all live, where we'll talk with various different paleo staff and the field crew and look around the museum and see some of the fossils actually on the various cameras that we've got. And we can answer your questions and show you things. If you want to request specific fossils, then please do. We'll have all kinds of stuff to show you. So first of all, some of the people that you'll be seeing. I'm in the top left corner, Dr. Denver Fowler. I'm the curator here at Badlands Dinosaur Museum. In the top right corner, Dr. Liz Friedman Fowler. Liz is my wife, but she's also a paleontologist, and she specializes in duckbills. So we'll bring her in and she'll make some comments about duckbills quite a lot. Bottom left, Amanda isn't with us because she broke her leg a little while ago. So I've been building up a collection of things for her to put in our collections when she comes back. And we wish her all the best. And then Deanna is our contractor preparator. She works on a lot of the very fragile, light, awesome little fossils that we're collecting from one of our sites. We're very lucky to have her. She's on a contract that's partly funded by the Bureau of Land Management, a grant that we got from them, so we're very appreciative of that. Garrett was our summer intern and prepped a few of the fossils and did some summer programming. And then Steve is our main preparator in the lab and manages our various volunteers, of which we have a whole bunch of new volunteers this year. The local newspaper put out an ad, or an article, I should say, the Dickinson Press. They put out an article about volunteering in the lab, and we got some new volunteers from that. And some people come in every day. It's great. John and Rodney are here almost all the time, and they've got up to a level now where they're doing top level prep on some of these bones. And it's speeding up the processing of the material that we've been collecting. And various other people there. Ty, you'll see some of his painting work through here, and then you'll see Brian as well. So if you would like to volunteer in our lab or on our field crew even, send me an email or go to one of our websites or the Facebook pages. You'll find details of our volunteer program there. So what's going on in the museum? Well, the elephant in the room is the expansion. So we are expanding the museum, and we're supposed to be breaking ground this spring or summer in 2026. And the little tiny spaces that you'll see in the video at the end of this broadcast will be vastly increased. Our lab will increase by about 4 or 5 times, and our collection space will be big enough to hold about 400 collections cabinets and various oversized storage. So much, much larger than the rooms that we currently have. And this should make us one of the biggest fossil storage repositories in the region, because we're a federal repository since 2018, I think. So all the fossils that we collect on federal land are permanently stored here in Dickinson. One of the things we're really hopeful for is when we get a bit more space in the lab, we can fit more volunteers in. We're already very excited about setting up new volunteer tables and getting more of these bones prepped. And that'll be all visible with glass. You'll be able to see into the lab even more than you currently can. So it should be a really great update, and we're very excited to see it. As you'll see at the live bit at the end, we're pretty cramped back here because we've got so many big fossils and they take up all of our space. So some of the new things, just in terms of donations this year. This is a really cool thing that was donated by Betty Leppert from her husband Gary's collection. This is a hell pig snout. You can see on the left there, that's me earlier on today holding this thing up. This is the snout of a hell pig, so either Archaeotherium or Diodon. They're called hell pigs, but they're actually, I believe, more closely related to whales. And this one was, I believe, collected just south of Dickinson in an area called the Little Badlands, where we have an outcrop of a formation called the Brule Formation and various of the White River Group parts. So this is about 35 million years old. It's Eocene, a Oligocene boundary kind of age. And we also had an Oreodont skull donated as part of that collection. So I'm going to get a 3D model of the back of the skull that's missing on this hell pig, print it out and put it on display. We already have an Archaeotherium skull, but it's much smaller than this one. This one is huge. So we should have a really cool exhibit of these hell pigs coming shortly. Some other donations. This is our state fossil. All the school kids love it when I bring this up because they're all expecting me to say our state fossil is like Triceratops or T-Rex. But no, it's Teredolytes, which is fossilized wood with shipworm borings. And it's a quite common fossil here in North Dakota. These ones, I think, are 55 million years old. And all those weird little grey lines you can see are actually these shipworm borings where they've been filled in with calcite. And the whitish coloured stuff is the petrified wood. So we get some really huge petrified logs, even here in Dickinson. There's lots of them around town. And in fact, my neighbours and a few other people in town build barriers around their houses because some people who can't drive sometimes bump the curbs and slam into people's hedges and things. So they've built barriers of fossilized wood around their house, which I think is pretty cool. But anyway, you can see huge logs all around town. And thanks to Brian Nelson for donating these huge lumps of our state fossil. So what else is new? In the lab, Steve will love to show you some of his new toys in the lab. We got a grant from WSI for some ergonomic adapters for our microscopes. So they all have these eyepieces that can move and make you a bit more comfortable when you're using them. Because obviously many of our volunteers and our prep staff are using these for hours and hours and hours all day, every day. And they really are actually super comfortable. That sounds kind of a weird thing to say. I'm not just saying that. We just got a custom articulated microscope arm, which Steve will love to show you. We can stream video from that. That was funded by the Southwest North Dakota Museum Foundation. And specifically in the photograph, you can see it looming over the articulated Tyrannosaur skeleton, Denver's Tyranno. So it's especially helpful for that because it can be bent into all these different spots and it has a really good focal length and it's well lit and all sorts of other things, which Steve will tell you all about later on. Ty, one of our volunteers, has been painting casts. So top left is a Champsosaur skull cast that he painted for us. And then the bottom right is a new nodosaur species that we dug up in 2017. This is the skull of that nodosaur. It's upside down. It's a little bit squashed, but this painted cast looks like the real thing. Ty is super talented, and we're very lucky to have him. And he's been painting all sorts of other things for us that are going to be going in the exhibit over the next year or so. He actually paints things so fast, I struggle to keep up with him. He just came and picked up some more things yesterday. He's very good. So a little update about our Tyrannosaurus sisyphus exhibit. So this is the holotype of Daspletosaurus wilsoni. We got the bones on display last year, but as of September of this year, we've got the painted skull restoration on display. So this was a model that was made by Justin, painted by Liz, and Wes Isaac did the armature for us. And this thing looks totally fabulous. So this is the complete skull of Daspletosaurus wilsoni. And of course, you can see the real bones that we have of this specimen right there next to that restoration. And you know, this is again a world-class specimen. It's the holotype of its species. It's the first one, and it's really cool. And we're very lucky to have something of this quality in our museum. And coming next year, hopefully, we should get its little buddy Holger. So this is another Daspletosaurus specimen that we collected with a partial skull, but we've got all the most important parts. And we're getting a 3D restoration made of that as well. In fact, we're getting lots of restorations done of all of our star specimens, if you like. Recently, I posted about these magnets I made and we put in the shop. So our Lambeosaurus, which is something we collected 2 or 3 years ago. We have that on display for about a year now, and I made a 3D model of it and we printed it out, and you can buy magnets, which are, let's say, museum quality. They are superb detailed magnets showing this Lambeosaurus skull, the only Lambeosaurus from the United States. We've had a number of visiting researchers this year looking at anything from frogs and leaves and theropod bones, little plant-eating dinosaurs. Zach was here just before the summer. And then most recently we were visited by Bismarck to see some of this new equipment that Steve's been putting in the lab. So as our museum grows, the importance of our collections grows and the importance of our facility and the equipment that we have is really cutting edge stuff. So people come to see that too. So on to the fieldwork part. I'm sure that's what people want to see. So we do fieldwork in a couple of different formations. We work in the Hell Creek sometimes. I'm not going to be talking about that this year, but that's about 66.7 to 66 million years old. It's just before the dinosaurs go extinct at the KT boundary. And we also work in the Judith River Formation. This is about 78 to 76 million years old. And we work across it all across northern Montana. We do 3 months worth of field work, basically all of June through to the end of August and sometimes September as well. And we work on public lands. So that's land that's almost entirely managed by the Bureau of Land Management and by the Bureau of Reclamation. Occasionally we work on state land as well, but we haven't done so the last year or two. So the Judith River Formation, this is what North America looked like when the Judith River was deposited about 78 million years ago. Notably, there was a huge seaway that split the continent in two, and deltas would build out into that seaway from the mountains and basically fill in the sea in the area of northern Montana and eventually North Dakota. So as the sea level rose and fall, the sea would come and go back and forth over those sort of 12 million years or so. So this is the Judith River of Montana, where we do most of our collecting. It's the big purple splodge at the top of the map. And we work all the way along the border, basically, between Montana and Alberta and Saskatchewan, in about 3 different places, depending on what time of year it is and how flooded the rivers are, so we can drive across them. So we do a mixture of finding new sites and then working old sites. Some of these are just surface collected, some of them are big quarries. So our first big dig is Jack's Bone Bed. So this is an awesome site that Jack Wilson found in 2020. This is probably our premier site now. And to begin with, it was fairly modest, I think. We had just a few bones poking out of a sandstone over a big area, so it looked very promising, but you never know. But over the last 5 years, we've dug in, we've done extensive excavations, and found a wonderful representation of the whole fauna. To begin with, we thought this was a hadrosaur bone bed because that's what we've been finding, hadrosaur bone beds, and we can see hadrosaur bones sticking out. But as you'll see, this has developed into what I might pitch as a Concentrat Lagerstätten, so a superb site that has everything. It has every animal of the fauna. It's quite amazing. So yeah, and originally we were finding large bones, mostly from duckbills. And most famously from this site, one of the first things we found was the skull of Liberty the Lambeosaurus, the only Lambeosaurus from the United States. All the rest are from Canada. One of the most complete known skulls. We also have a skeleton to go with it, and you can see the skull on exhibit in our hall. Last year when we were digging, we discovered there's skin all over the postcranium of this thing. It's got it on the feet, it's got it all around the tail, the shoulder. It's unpredictable and it's chaos to work with, but it looks amazing. And the bones are all crisscrossed around each other, so they're troublesome to collect. But we got the postcranium in a big jacket and we're going to pull it out this coming year. So that's what this site was most famous for. But we actually have a second duckbill skeleton at Jack's Bone Bed. And some of the pictures I've shown in past years, these large duckbill limbs, these are all coming out at one end of the main quarry. The Lambeosaurus actually comes from about 20 meters away in the same level, a bit deeper in this old channel. But these large duckbill limb bones, were most of what we thought we would be collecting from this site. But as we collected more and more of them, we've not got any that are repeating themselves. We've got like 2 tibiae, we've got I think 2 humeri, fibulae. We're starting to build a skeleton, it would seem. They're all size consistent with each other. There are other duckbill bones in this bone bed, but they're not as big as this animal. So here's a few of those big limb bones that have been cleaned up recently. John Zink, one of our new volunteers, has been working on some of these big bones. So here's some of the ones that I think he prepped all 3 of these, but I could stand to be corrected on that. But anyway, so we've got some of those big bones prepped. And then last year, Jason found a pelvis, a sacrum actually. And we're like, oh, so is this thing another Lambeosaur? Well, here's that sacrum cleaned up. So this is where the hips fit onto the spines of the back. At the same time as finding that sacrum, just to the left of it, we found an upper jaw, a maxilla of a duckbill. And it was very big, and it was quite unlike what you see in these lambeosaur hadrosaurs, these crested hadrosaurs. So we knew that it wasn't from a lambeosaur. So that's what the big red X is. No, it's not a lambeosaur. But could it be from something like a Prosaurolophus? That was kind of our idea based on this maxilla. Well, help for that question was discovered this year. Brian, working at one end of our quarry, came across a brain case. It's right there at the bottom of this picture with the dark, it's the dark brown. There's quite a bit of it there actually. And the brain case is really important because it's where the crest attaches. It attaches onto the frontals of the brain case. And as you can see, these different species of hadrosaurs have different shaped crests. So on the two on the left-hand side are lambeosaurs, Corythosaurus at the top and Lambeosaurus at the bottom. And on the right-hand side, we've got the hadrosaurines, and they have those bigger upper jaws. You can see they're a little bit bigger. So yeah, this is going to be a hadrosaurine. And if we've got the brain case, if we can see how the nose crest attaches to that brain case, then we can determine what species we have. So here's Brian's brain case getting the full attention. That's Liz checking it out. And it was quite the celebrity specimen because we were super excited. And there it is on the right. It doesn't look like much, but when it's cleaned up, it looks like this. So the underside view, you can see the cavity where the brain was. It's incredibly small. That's a bit insulting. It's not tiny, but it could be bigger, let's say. And then the important parts are actually along the top border on the upper side, because that's where the crest would attach. So if we make a comparison here, I looked through all the books and Liz looked through the books, and we basically were looking at the contact between the frontals and the bones that stick to them, like the nasals and the prefrontals. And you can see this kind of wiggly lines there, and the shape of those wiggly lines tells us what we're looking at. And our specimen looks the most similar to Griposaurus. So this is what Griposaurus looks like. It has a kind of arched nose, and this is a really big Griposaurus. Like, it's not a small one at all. So we're quite hopeful that we can get more of this skeleton and restore it for the museum. But anyway, there's a reconstruction of the skeleton. We've got quite a few vertebrae, quite a lot of legs. That's not our skeleton, but we will hopefully be able to produce something like that eventually. So our second hadrosaur at this site is a Griposaurus. That's pretty cool. Here's some random cool things from Jack's bone bed, because one of the things about Jack's bone bed is it's a real jumble. I'm going to talk about this in a little bit, but this is a channel. Things died. They fell into the channel and washed up on riverbanks, and we find just bits of everything. And here are some samples of some of the different animals that we found. So this was a cool bone that got cleaned up this year. This is a femur, a thigh bone, and it's from a baby hadrosaur that's just out of the nest. You can see in my hand, it's not very big, but it's also not tiny. So that's why it's just out of the nest. So this is not a hatchling. It's not an embryo. We might think those really tiny embryos and hatchlings are very rare to find. And they are, relatively rare. But one of the things about eggs and nests is the nestlings will stay within the nest structure, at least for a little while. And so if the nest is destroyed by a flood covered with mud, you get those nestlings preserved. So nestlings are actually more common than this body size. This body size is like they've just left the nest and they're roaming around the landscape, eating and growing, although this one didn't last very long, evidently. So this is from just a small individual. It might have been like a meter long, something like that. And we've also found jaws. So this is a jaw from the same site, around about the same spot as this femur. So we might have a partial skeleton of a young, just out of the nest hadrosaur. It's probably a lambeosaur, this one, given the shape of the jaw, but we're not quite sure. We actually have a couple of jaws that might be from the same individual. One's got teeth in it, but we have to clean it up. But this is pretty cool. Like, this stuff is rare. Here's another lambeosaur bone. So this is a frontal. So this is the front of the brain case. I'm going to be talking a lot about frontals today. Because, frontals are great because they're a diagnostic bone. Like I was saying before, if you find the brain case, you can look at where the crest attaches, and that tells you a little bit about, or tells you what species you have. Even if you don't have the crest, you can sort of see where it attaches. So this is a frontal for a young lambeosaur, and we have one on display. That's the bottom right corner, and so I've got a little arrow pointing to which bone it is. And when they're young, the crest hasn't yet sort of reached back to the frontals and the parietals, so it isn't necessarily fully developed yet. But one thing that's cool about this frontal is, if you look closely, you can see all sorts of wiggly lines on it, which we were quite excited by. And if you're thinking what I'm thinking, ramiform endocranial vascular valleculae, you'd be correct. And in English, that translates as the impressions of the blood vessels on the surface of the brain. And these are quite rarely observed. They have been documented in these lambeosaurs before, but these ones are really beautiful. I'll skip back a little bit. They're really well indented. The photograph doesn't do them justice, and you can actually see where they branch. You can see where some overlap. People who study the brain anatomy of dinosaurs would probably be very interested to see this specimen. And it's only, I don't know, a week ago that we really picked up and looked at this thing properly. One of the effects of this is that because those blood vessels are on the surface of the brain, and the brain is very tightly held within the brain case. So those blood vessels basically get pushed up into the bone, and the bone forms around them, so you get the impressions of the blood vessels. Now, one of the cool things about the brain fitting tightly into the brain case, that means if we have a brain case, we can use the size of that brain case to estimate the size of the dinosaur's brain. So that's part of the justification for basically measuring that empty space and saying that's how big the brain was. But I'm hoping that somebody can look at these blood vessels and map out which ones are veins, which ones are arteries, what they're doing, what they're called. It's really cool. I was super excited. I want to make a really good 3D model of this and map them out or something, and print it out big so you can see it better. Something really cool. Here's a couple more random things. One thing about Jack's bone bed is we never really got much Tyrannosaur material. We have teeth, of course, or bits, but we got our first piece of Tyrannosaur skull this year. This is a splenial, so this is, on the person's left-hand side, I think that's Steve, you can see the splenial of B2, the holotype of Daspletosaurus wilsoni. And in the right, you can see the new specimen. So we're getting, hopefully, a partial Tyrannosaur skull out of this site. Who knows? Like I say, this is the first Tyrannosaur skull bone we've had from this site, so I'm not surprised, anymore, because it keeps producing so much great material. On the right-hand side, it's the same bone, just flipped over. This is another frontal. And this is fairly typical for the kind of preservation we sometimes get at this site. Some bones are pristine, others are a little bit worn because they've been bouncing around a river a bit. Sometimes they're worn on one side and not on the other because the river's sort of eaten away at one side of them as they were sat there. Anyway, this is a frontal of another hadrosaur. Probably, I think, a lambeosaur. Well, maybe not actually, because I haven't really thought about that. But the interesting thing about this frontal is if you look in the bottom right corner, let's see if I can use my virtual laser pointer. I don't know if it's working. Oh, there we go. This area here, this is a tooth mark. That's a double tooth mark. There's one there and there's one here. And that is where a Tyrannosaur has basically bitten into the brain case of a hadrosaur. That's pretty cool. I love tooth marks because they show behavior. And on a frontal, that's pretty cool. You find a lot of tooth marks on limb bones, where they're scraping big leg muscles off of the limb bones. But to see tooth marks on the brain case area is actually pretty awesome. And it looks like in that cavity, yes, with my little laser pointer again, this cavity here looks like the tooth mark went really deep, which is quite typical of Tyrannosaur feeding. But even so, it's a cool specimen that will need to be described and figured. So there's a couple of little treats. This is something that Steve prepped a little while ago. It wasn't in last year's presentation because we prepped it after that. But one thing we've been getting from Jack's bone bed is mammal jaws with teeth in them. If you find them without teeth, they're nice to find, but they don't necessarily tell you what species you've got very precisely, or at least as precisely as mammal paleontologists like. So when you find them with teeth in like this, it's really cool. Now, the one on the left was prepped by Steve about 9 months ago, I think. Beautiful little thing. It's really small. You can see by the size of my fingers. Really, really small guy. A little marsupial. About 76 million years old. The one on the top right was actually found this summer. It was in a jacket, I think, from 2024, which was being prepared. It had a limb bone or something in it. But anyway, when the jacket was flipped over and opened up, it had a beautiful mammal jaw in the underside. And this new mammal jaw is actually quite a lot bigger than the one on the left. It's about 2 inches long, something like that. Maybe that's a bit of an exaggeration. Maybe it's only an inch, but it's a lot bigger anyway. It's a much bigger species. And Steve's looking into doing more live stream preparation from our lab, and he would be really keen on prepping these little tiny jaws. And we have a whole bunch of different animals' jaws from this site. We have multiple mammal jaws, but other things as well, as you'll see. I just put this in just because I think these are awesome when we find them. At this site, there's a great big Basilamis turtle that its shell has broken up and been scattered across the site. And these are huge turtles that lived in the late Cretaceous. And yeah, we find huge chunks of its shell across the site in just different places, as is the nature of this site. Everything is scattered pretty much. But we've also started to find some of the armor scoots off its arms and legs. It has these big spikes on its arms and legs. And on the left here, you can see 2 of the hand claws. So these are actually the claws from its hands, its feet, which are really quite sturdy. They're cool when you find them. I mean, all claws are cool, but these ones just like great big solid lumps of spiky bone. So we have a lot of other turtle fossils from this site too. We've had some beautiful skulls in the last couple of years, which are being studied down in Arizona. One of them has been published already, but there's another and even nicer one which is in the works. And then we have this slide. We have a jumble of small theropods and other fragile beasts. Well, what do I mean by that? Well, the only boring thing about Jack's bone bed is its setting. It is a channel. It's a channel where animals died, they fell in a river, they floated along the river and they got washed up on the banks of the river. And that's what this site records. Lots of things being washed up, and eventually this channel shallows and actually becomes a leaf bed. It's full of leaves at the top. I haven't got any leaves in this talk, but anyway. As part of the evolution of this channel, it goes from being a deep channel to shallowing into these little braided streams. And all the animals that washed up, they sort of get swooshed around. So they're all mixed up, and we get a lot of really cool, as you'll see, small animals, raptors, birds, etc. But they're all jumbled up. So when we find these things, they can be anywhere along the quarry face. And it seems like we've got about 5 different skeletons at least that are all jumbled up together in these little lenses of gravel, which is what we're targeting and really reaping the rewards. And those mammal jaws and everything are in the same layers. We collect all that matrix now for screen washing too. So back in 2022, I started talking about this troodontid that we collected. So we got a number of bones, vertebrae, limb bones. The best, most important bone from these guys is the frontal. So you can see it there on the top row. And that tells us that this thing was a troodontid. And then I presented some bones from last year as well. We've got all parts of the skeleton of this thing. So it's either a Stenonychosaurus or Latinovenatrix. So we've been collecting more small theropod bones. Most of them, though, I don't know if they belong to this troodontid or not. And that's why I haven't updated this diagram. Some I can say belong to the troodontid. This is a brain case. It's a beautiful 3-dimensional preservation. You can see on the left-hand side there, let's use my little mouse pointer again. This is the ball that fits into the neck. This little hole here is where the spinal cord enters the brain case. It's beautifully preserved. We'll be able to CT scan it and look at the shape of the brain inside this brain case. And this compares very well with complete brain cases of troodontid from around the world. And if somebody asks, or I remember, I'll show you this specimen after this presentation, and you can see for yourself. But this is part of the troodontid. And it seems like we've only got one skeleton of a troodontid, I think, so far. But one of the complications is from this year. So Dane Schwartz found this year. And this is a frontal. Again, I've been talking a lot about frontals. There's more to come. This is a frontal from a little dromaeosaurid called Sauroornitholestes. So we found one of these before at a different site that Jack Wilson described a few years ago, I think 2021. That's on the left in this left-hand picture, the white one. But the darker coloured one is the one that Dane found this year, and that's at Jack's bone bed. So it's a little bit smaller than the troodontid, but it just means that if we find like a phalanx or something like that, it could belong to a Sauroornitholestes instead of the troodontid. So that adds a level of complication because the preservation of their bones is very similar. It's this kind of dark brown, glassy kind of preservation, but still mildly robust. So yeah, you're looking into the brains basically of a little raptor right there. And you can see the orbits where its eyes would have been. I should really do this again. This is the eye socket here. This is the cerebrum and the olfactory smelling lobes of the brain are in this area here. So this is actually a really important bone to find, the frontal. It's diagnostic and can tell you what species you've got. So that's one of the reasons why I can say this is Sauroornitholestes. So yeah, that's another raptor coming out of this site. This site we also have a bird, at least one bird I guess. It's an associated leg. We found the metatarsus last year, and if you saw this presentation last year, you'll have seen that beautifully prepared by Deanna. And then this year we got the distal end of the tibia, so that's the shin bone that attaches to the metatarsus. So the metatarsus is where the toes fit into, and then the tibia goes from the knee down to the ankle. So we've got an associated tibia and metatarsus, the lower leg of this bird. And, you know, we have little claws, little phalanges from very small animals. And given that the way things are scattered through this site, it wouldn't be surprising at all if we actually had some of the toe bones and other bones from this bird. The bird bones are very fragile, very thin-walled. They tend to be dark in colour, so we're getting better at distinguishing them. But again, that's one of the challenges with this site, is it is a big jumble. We also have a parrot mimic raptor called an Oviraptorosaur coming out. And this is one of the more recent things that we've realised is also present at this site. I think last year I showed some of these bones. There's a humerus there on the left. We've got this limb bone on the right. We've got vertebrae. We've got claws. We have more bones of this thing now. In the top here, I'm pretty sure that is a radius. So that's one of the forearm bones of one of these oviraptorids. It's a caenagnatheid, not an oviraptorid. And we also have the first toe metatarsal. So that's kind of in us it would be the big toe or the thumb of the foot. But that's what they look like in these Oviraptorosaurs. And at the bottom is a pterosaur neck vertebra, which I'll talk about in a bit. We also have this awesome ilium. So this is the hip socket. This is it being cleaned up by Deanna. And here it is all clean. So we have the hips of this thing. And then just recently we prepared this bone that was collected last year. This is the wrist. It's an articulated wrist and palm of the hand of the same specimen, presumably. It's size consistent with those other bones that we've got. And at the top, just highlighted there with a dashed red line, this is what's called the semilunate carpal, the wrist bone, the shape of the half moon. And it's weirdly twisted. And when this animal flexes its wrist, it actually folds its wrist up like a bird's wing. And, or rather, birds, when they flex their wrist, fold the wing up like a primitive raptor would, because they evolved it first, presumably. And then we've got two metacarpals from the palm of the hand. Now, we have other bones, presumably from this animal. We have actually another semi-lunate carpal that's just isolated on its own, that was floating in the sediment, and numerous toe bones and finger bones and claws, which we're trying to differentiate all these different animals. But as if it wasn't difficult enough with those raptors, we also have the pterosaur. This is a little summary of some of the bones that we have. We found a new humerus, so we have both humeri, so that's the upper arm bone that provides the power stroke for the wings. Because yes, pterosaurs are these flying reptiles that lived alongside the dinosaurs. They have air-filled bones that are very lightweight and fragile. So we have a number of wing bones, these long, thin, easily crushed, usually crushed, wing bones. We've gotten good at spotting them and saving them. We have 3 neck vertebrae. Neck vertebrae are diagnostic for these animals. We have a new one that was, we used to have 2 neck vertebrae, but now we found a 3rd one just a few months ago, which is super cool. It's really nicely preserved. We have parts of the wing metacarpal. These are wing bones. These are the phalanges. These are the tips of the wings. And I've written at the top of pterosaur bone bed. That sounds kind of crazy. You know, pterosaurs are super rare. But, you know, could we have a bone bed of them? Well, the interesting thing about these 2 bones is the one at the top is quite small, but it's from behind the Lambeosaurus skeleton that we collected. So it's from about 20 meters away from the others. Or 10 meters away, maybe. All the other bones come from the same spot in the main quarry. And that lower bone looks very like the upper one. It's just a lot bigger. So we haven't got any overlapping bones other than maybe this one. But it's not beyond the realm of possibility there might be multiple pterosaurs preserved in this bone bed. We're keeping an open mind about it. I expect most of the pterosaur bones that we get from the main quarry will be from one individual, which is a quite small individual, actually. But it'd be really cool if we had multiple pterosaurs coming out of this site. So this is a nice skeletal diagram that Danny Barrera did for us as part of a BLM-funded grant to draw all of our star specimens. So it doesn't look like much, but this is one of the most complete Asdarchid skeletons from North America. Now, of course, there are all these fabulous pteranodons and other pterosaur species from places like Kansas in those western interior sediments. But when you get inland, when you get into these land deposits where these big Asdarchids like Quetzalcoatlus lived, there's not many good associated skeletons. You know, you might, if you're lucky, you get 1 bone. And this is a dozen bones, maybe more now. We've got all parts of the skeleton. We've got parts of the foot. We've got parts of the wing. We've got neck. We've got little bones from the hand. Hopefully we'll find some parts of the torso. We might have part of the skull. We might have a lacrimal from this thing. It's weird and big and funny looking. It could be Cryodracon. That's a Asdarchid named from Canada, from the Dinosaur Park Formation, about the same age as this one. But our specimen is very small, not tiny. You know, it's still got a sort of a 3-meter wingspan, something like that. But it's a young one. It's really cool. I'm super excited. I love coloring in all these little bones on this diagram. So we want to get a restoration done of this too, and have it flying through our exhibit hall and through the airport as well. So yeah, one of the most complete Asdarchids from North America, and one of the 5 or 6 random fragile looking animals from this site. And we still have a shelf full of these fragile bones in jackets. These are all from this year. And we have a whole drawer full of smaller ones that were just able to be put into bags instead of having to sit on a shelf like this. And Deanna is slowly working her way through these, doing a fantastic job, as you've seen. Every one of these jackets, we put a big star on it. This is Deanna only, and it's they've all got something fragile. Could be a theropod, could be a bird. It's all interesting, cool stuff. So is Jack's bone bed a Lagerstätten? And Lagerstätten is like a, I should really know what that translates as, but it means like a special site of extraordinary importance and preservation. Places like Solnhofen is a Lagerstätten. Obviously, the preservation at this site, we do get skin, which is less rare than people think, but still quite important. But the concentration of these fragile animals and the representation of the whole fauna, including the microfauna, like salamanders and frogs and all that sort of thing, it really is an exceptional site. And we're very lucky to have come across it. And thank you to Jack Wilson for spotting it in the first place. We'll be working this, I imagine, for 20 or 30 years and really building a huge collection that'll give us a window into the ecology of this middle dinosaur park formation, Judith River equivalent area. So a little bit distant from there, the Big Digs 2, Cobb the Nodosaur. So this is about a 5-minute walk from the Lambeosaur, Jack's bone bed site. And Steve took his crew there. In 2020, Jack found some bones sticking out. They're very weathered. We weren't even sure if it was a ceratopsid or an ankylosaur. You get a lot of ankylosaur armor at these places, so finding armor by itself is not necessarily an indication that you've got a skeleton. But we went there in 2024 and did an excavation, hoping to find something. And we did. We found more bones. And most notable, that original discovery by Jack sticking out was part of the pelvis. And as Steve's crew dug in deeper, they found basically a complete nodosaur pelvis. So this is I showed last year. This year we went back. We did lots of new overburden, or rather Steve and his crew did lots of overburden. I wasn't down there. And found more bones underneath there. Now, it's a different matrix and it's not as quite well supported as Jack's bone bed. So a lot of the bones are kind of smushed. So this is the lump, and at least I call it the lump. And it looks like just a sort of smeared blob. It's actually got really good detail. And it's all kind of fused up too. So it looks like what this is like a fused up area of the big plates that cover the neck. And they do look like this. They're kind of flat and they have these large blood vessel holes in them. And we have a few of those from this site. We've collected a nodosaur in the past, which had quite a lot of these neck plates. And this is very similar. So it's cluing us in as to what we're finding. And then we collected lots of other bones. Steve currently is cleaning up this top right bone, part of the tibia, some nice vertebrae. And that bottom right thing is another armor plate. Looks like a big round blob, but everything looks kind of like a big brown blob when it's a dinosaur bone. So this is what we have of it so far, we think. It's a bit guessing in certain places, but we have lots of ribs, vertebrae, some of the major leg bones. We have some partly articulated foot, which is quite cool. And we think some of the big plates from around the neck and along the side of the body. So we'll be going back there in 2026, and Steve will be leading a crew there to dig up that animal. And I probably should have said at the beginning, actually, it's an armored dinosaur called a nodosaur. And either Edmontonia, Panoplosaurus, there aren't any named nodosaurs from the middle of the dinosaur park formation, so it's possible it might be something slightly different, but we'll see. You know, you've got to find just the right parts of the skeleton to be able to tell that, but it's looking promising, looking promising. We also prospected for some new sites, especially on the Bureau of Reclamation, where we had some new areas we hadn't been to before. This is a site that I found called Double Yoke, a dinosaur egg site. So if you'd watched our broadcasts in the past, you'll have seen Deanna found an egg site a couple of years ago, which had embryos of baby duckbills and various eggs that had probably hatched with the eggshell sort of smeared all over the place. Well, we came across this site. We found a nice, there's Andrew there on the right. We found a nice tyrannosaur tooth sticking out. And so we started looking very closely at the ground along this little ridge. And at one point, I started spotting some eggshell. And having seen Deanna's site from a couple of years ago, I thought, all right, there's eggs here. There's probably eggs here. We're at just the right level in the formation. And so I looked real hard, and you can see these 3 smeared areas. That's where I've put glue over the mud, but that's where there's eggs coming out. There's eggshell that's connected together. So I could see 3 spots, presumably 3 eggs coming out there. So we dug in. Oh, there's a close-up of the lower one. So it doesn't look like much. You know, it's just an orange-coloured bits of eggshell. So we dug in and we found more eggs. And they, again, don't look like much, but this is those eggs. There's 2 or 3 on the bottom edge that have been worn away a little bit by modern weathering. But the 2 at the back, at the top of this picture, those are basically intact. And if you look inside those white circles, you can see some flat yellow parts. We don't completely expose the bones when we find them. We don't completely expose eggs because they're very fragile and they need to be properly cleaned up in the lab. So we just sort of work around where they are and jacket them and lift them out. But there are 4 eggs here. They're not all touching like you might have seen some dinosaur eggs, dinosaur nests. They seem a little bit scattered. What's interesting about these eggs is they're intact. So at Deanna's site, the eggshells were kind of broken and smeared across the surface. That suggested that maybe these eggs had hatched. And also Deanna's site had embryo bones all across the surface. And embryos or hatchlings maybe. These eggs and this site, we didn't find any embryo bones at all. Not one scrap, but plenty of eggshell. So I suspect that these are unhatched eggs. And looking at them, you know, they're completely intact. They're all the way around by the looks of it. And we haven't cleaned them yet. We should get on with that. But anyway, very promising. This is also in the same horizon. That's a little infilled burrow, probably made by an insect or something. This is of interest because when you're laying eggs, you want to lay them on a stable land surface. You don't lay them in a swamp. And stable land surfaces are often marked by these burrows. So animals burrow into the surface, and then sometimes those burrows get infilled with sediment or minerals and are preserved. And so there were nice burrows preserved in the same level as the eggshell, as the eggs, I should say, which is consistent with what we know about nesting sites for other dinosaurs. And the cool thing about this site was there's eggshell coming out on either side of this little ridge. So I suspect when we go back next year, there'll be more complete eggs under the surface, not far down, all the way through to the other side of the ridge, probably over about 6 foot square, or maybe a bit more than that. So that's really promising. Quite excited about that. Here's a little site at Uplag. Now, we had a couple of these bones last year, the claw and the bone in the top right corner. That's a little toe of one of these orodromines. So Zach was one of the visiting researchers from before. He visited just at the beginning of the summer, and he was really excited to see these things. And then this summer, Pietro Sidoli, a student from Italy, he was up looking at this site, Uplag, and found more orodromine bones. He found a little spike, and I didn't know what it was. It was like, it's not a ceratopsine. It's not one of the horned dinosaurs. It didn't look like anything I'd seen before. And it's a cheek spike from an orodromine. And these are small plant eaters. They walked on 2 legs. They looked a little bit like hadrosaurs, if you like, but they walked on 2 legs, and they were much, much smaller. They get to like 2 or 3 meters long. Later in the Hell Creek, they get a little bit longer, about 4 meters, something like that. But these ones are much smaller. And they're actually very rare. There'd only been, well, there hadn't been any officially documented orodromine bones from the Judith River Formation. And we had one partial foot donated a few years ago. So I was already working with Clint Boyd at Bismarck Museum on some of the orodromine things that we'd had. And then Zach visited, and we were all working together on this stuff. And we started going through the collection looking for these things. And I'm getting a lot better at picking them out. And anyway, looks like we've got an associated toe because they're all from the same site. That top set of 3 bones, including the little claw, and a cheek spike from the same site. Now, It's a bit of a random collection of bones again, but we do get some associated animals there. So maybe we have a bashed up skeleton of an Ardromene coming out of Uplag. That'd be pretty cool. Here's some other random bones from some of those microsites. I've probably got about another 5 minutes left of the slides. Top left is a vertebra from a lizard. These are always cool to find. You find lots of fish vertebrae and things like that, but lizards are quite rare. Next to that, there's a little lizard jaw with teeth. Bottom left corner, there's a salamander jaw. This is actually quite big for a salamander. It's not been cleaned yet. If you look very closely, you can see some little vertical ridges along there. Those are actually the tooth sockets. So a salamander that would have lived alongside the dinosaurs. These are some of the specimens that Steve might be prepping under the microscope as a live stream. Just going to have a quick drink, drying out. Sorry about that. Yeah, so Steve might be prepping those under the microscope. Top right corner, this is a little Tyrannosaur hand claw, apparently. I collected it, it was a claw, and I'm supposed to be an expert on claws, but I've not seen many Tyrannosaur hand claws, so I didn't know that's what this was. But we had a commenter on one of our Facebook posts who said that's a hand claw, and lo and behold, all the comparative material says that's what it is. So that's a little hand claw from a young Tyrannosaur. And the bottom right corner, it's just a fragment, but this is a frontal from a baby Pachycephalosaur, so one of the dome-headed dinosaurs. We've actually had some luck in finding dome-headed dinosaurs. But this is one of the smallest, if not the smallest we've got, I think. On the left-hand part of it, you can see the cavity where the cerebrum would be. This is a jaw, Hadrosaur jaw, that Xanadu Biondi found, probably from a Lambeosaurine. What's cool about this, from my perspective, is that just around the corner from where Hadrosaur jaw was found, Chalfant found a horn of a little Ceratopsian. It was in many, many pieces, all scattered down that little brownish wash area you can see, where the yellow arrow is pointing, Charles' horn. Now, when we collected it, there were two main bits. You can see the horn, you can see the back of the horn, but we were missing all the bits. So we collected a big bag of every bone scrap from that area, and we got it to go together. I was super pleased, super pleased. The yellow arrow in the bottom right corner is pointing to a little lump that we collected as part of that very careful screening of the spot. And that's the only bit that clicks the two main chunks together, which is just great because we can see exactly the shape of the bone. And so this is a horn from a juvenile or a baby Centrosaurus, probably Centrosaurus brinkmanni. There's a little bit of frill with this specimen, so there's more than one bone there. So there might be a partial skull slowly weathering out. We'll have to check on that site next year. But this is a cute little thing to find. I work on horned dinosaurs the most, so I love to see these things. We've got so many duckbills, I'd really like another new Ceratopsian. Here's the mandatory Tyrannosaur tooth slide. We find lots of Tyrannosaur teeth out in the field. Some various different ones there. Top left you can see a spalled, so that Tyrannosaur bit into some bone and broke its tooth. And that's quite common for Tyrannosaurs to do because they would replace their teeth through their lives. So we see that quite a lot in working with some people on that sort of thing. Oh, this is quite cool and appropriate as I'm talking about biting into bone. Joe's Micro, tooth-marked limb bone. Last year, I think I mentioned this. We collected this into 2023, but then I completely forgot about it. And I started piecing it together last year and got quite a lot of pieces together, but I couldn't make them all go together as one. And it was really interesting because it's a leg bone or maybe an arm bone of a duckbill, but it's covered in these tiny tooth marks. Maybe these are raptors or maybe they're baby tyrannosaurs, but there's loads and loads of them. And they're really cool. They're beautiful. And they're all around it. They're not just along that ridge there. So I wanted to make these bits fit together. So we went back to the site. It's a site that we found in 2018. It's produced all kinds of small fossils. The area where that bone came from, is just over here. And we collected some more pieces, and I got one piece that made it all click together. I was so pleased. And so there's the whole bone. It's probably the most tooth mark bone that we have in our collection. And of course, it's interesting because the tooth marks are so small. We have quite a lot of bones that have big tooth marks from like big tyrannosaur bites, but not many that have these little bites. So I'm very interested to see what those might be from, if we can tell at all. But while I was collecting the loose pieces of bone, or at least looking for them, I noticed just to my right, here was this other thing. And super rare, the bottom left corner. What is this? Looks like a pile of cornflakes. I knew instantly what it was because I've been looking for these things for a while. Well, this is what we're looking at. It's a frontal, again, so many frontals. Diagnostic bone, it's the bone between the eyes. It's from a very small animal. It's from a Paleoceniwa Komodo dragon-like lizard. Now, this is a slide from last year. We found a bunch of vertebrae of these things before, but we'd never found skull material from them before. I found a few smaller specimens, but this one's pretty big, and the vertebrae suggested these big ones were in this area. So here it is showing you what you're looking at. Top left is the bone that we found. You can see on the right of that, there's a modern varanoid lizard skull shown with the frontal. So this is pretty big. This would have been a sort of 6 foot long varanoid monitor lizard, probably eaten some of those baby dinosaurs that we keep finding fossils of, and living a good life out in the delta in northern Montana, eating foolish baby dinosaurs. They would have been one of the big, mid-sized, small to mid-sized predators in this ecosystem. And these are super rare. So it's a cool bone to find, of course. It's a frontal, it's diagnostic, but there have not been many of these ever found. Paleoceniwa itself, or Paleoceniwa, I can't remember how it's pronounced, but it's described based on vertebrae, and it may not actually be valid because the vertebrae all look the same. Whereas these frontals, I think this is the only one from the Judith River Formation. There's one from the Two Medicine, and there's one from Canada. And I think that's it, as far as frontals go from this species. So, there might be one or two others, but it's super rare. It's one of the only ones known of its kind. And so I've been so excited about this thing, probably unreasonably so, but it's just one of the things I've always wanted to find. Dave DeMar over at in the Burke Museum, he's a specialist on lizards and salamanders and things. So I used to collect with him in the Hell Creek, and it was always special when I found him a new lizard bone. So whenever I find a lizard, I think of Dave. And Bob Sullivan down in New Mexico, who I used to be the field assistant for, he's also a lizard expert. So I love sending them pictures of the lizard bones that we find and sounding incredibly ignorant about what they are. But I was very pleased. So I like to end the presentation with a little picture of the different wildlife that we saw. On the left, you can see a bald eagle standing above the flooded part of the river in Hinsdale. Various other cute little bunnies that were very fast. Sitting under our jackhammer one morning was this rattlesnake. That was always nice to find. Top right corner, that's a horned lizard. Used to be called horned toads, but they're a kind of lizard that eat ants. And I had to send this information, actually. The Fish and Wildlife were doing a study on where these live. And we found a few pockets of them, hotspots for horned lizards, as we've been prospecting for dinosaurs. We see big ones and small ones, and this one's one of the biggest. And top center, we see a seagull who Deanna will attest was very precise. It had particular talents and liked to fly around our camp quite a lot. So just closing up these first parts of the slides, maybe you'd like to become a museum member and visit the museum as often as you'd like, bring the kids, play with the sandbox and the various different interactives and things that we've got. Discount in the shop, and it's still very cheap to be a member. If you want to volunteer in our lab or in the field program, drop me an email, go to our website and find our application forms. It's very important to me that we still have one of the only free field programs in North America. There's a lot of these places you can pay thousands of dollars to do a week's worth of digging, but we don't charge thousands of dollars. I think that you need to have science accessible to everybody. And so that's an important part of what we do. And we train all kinds of new and upcoming people, and I think we have a good time. And obviously, we're finding some really exceptional fossils as well. So if you want to volunteer with us, either in the lab or in the field, yep, drop me an email, etc. Go to our website, fill it in. Please consider donating to our program at, I can't read that website anymore. We used to be DickinsonMuseumCentre.com, but now it's got lots of slashes and things in it. But anyway, we've got a donate page as on our webpage. We've also got a Throne account where we're sort of raising preparator money. So we have a Throne account as well, Dickinson Dinosaurs Dickinson ND. And if you just want some really cool merch, go to our shop, shop.dickinsonmuseumcentre.com. We've got those magnets, we've got t-shirts, we've got postcards, and we're putting new things up there, hopefully next year as well, all kinds of pictures and artwork that we've had commissioned, all sorts of great things. Tomorrow is the open house here at the museum. So from 3 to 6 p.m., free entry, come in, there'll be some refreshments, there's Christmas decorations, cookies. Not if I get my way, I'll be eating all the cookies. But we'll be showing off some of the fossils that we've talked about today. If you do happen to live locally, come by tomorrow. You can see some of these things in person. And just loads of people to thank. Obviously, all of our donors, the Bureau of Reclamation and the Bureau of Land Management who give us the permits, but also some funding as well to go and work on their lands. All the tech support people who make this podcast, if you want to call it that, possible. Our fossil preparation team and our field crews who work really hard in very hot weather. Even in the lab sometimes it's hot in the summer. And I just want to thank everybody for watching this. I just wanted to post this picture of our camp and everyone oblivious to this big storm that's building in the distance. So thank you very much, and I believe we will now switch over to our live cams and take questions and comments and show you some things in person.
All right, am I on camera here? Am I live? Thanks everybody for being here. Appreciate you going through the presentation. Can't wait to show you some of the stuff we have in the lab right now, and then you'll go with Liz and Denver into collections. It'll be fun. So I'm Steve Clausen. I'm the Paleo Lab Manager here at Badlands Dinosaur Museum. Of course, this is Deanna Neff. She's our contract preparator. Bring in Dr. Liz Friedman Fowler.
Hello.
She's one of our field crew chiefs and a professor at Dickinson State University. Yep. Denver, I think, should just kind of quickly run through and say hello. He's just given you
Yeah, so you can
an
actually
hour's
see Denver.
presentation.
No.
This is what I look like. Yeah.
All right, welcome.
So we'll start right at the counter here. This is the lab counter. I have a lot of projects for volunteers. This is one that's lined up. This is from the Cobb site, our nodosaur that Denver just talked about. This is one of those cool ribs that have armor that actually attaches to the rib. So sometimes the joke is that ribs are very boring, and when we run into another rib, we just frown because this is something we have to deal with rather than have fun digging up. But these are really fun to dig up because they're just weird looking as far as ribs go. They're cool. This is lined up as a volunteer project, so if anybody decides to spend some time volunteering, this is an introductory level project. Being actively worked on as of earlier today. This is a Ceratopsian pubis. We don't have a lot of Ceratopsian bones from Jack's bone bed, so even a pelvic element is kind of neat to have and tells us something about the biota. I'm sure Denver can talk a little more about that. And once again, I believe I did this last year, but I'm still going to show off our really cool microscope gear. So we have these ergonomic attachments for our Swiss microscopes. So that's Leica, Heerbrugg. You see anything like that, you know that they're modular. So we can build Frankenscopes and make it more ergonomic for people to sit down and put their eyes comfortably instead of sit down and be fixed and have to crane their necks. I've been there. I prefer attachments like that. We're glad we have a lot of grant opportunities to get equipment like that. I thought Later today, if we have some time, we might open some little baggies from Jack's Bone Bed. So every day at the bone bed, we come out with at least one of these microsite bags. These are little bones that come out in one piece. We wrap them up in foil. We don't need a big plaster jacket for each of them. And most of the time, we either don't know what's there, or it's like a little caudal vertebra or something small, identifiable, safe to foil up. So it's always kind of a fun surprise when you open these. We have found pterosaur vertebrae in these microsite bags. It's just a little bone, I don't know what it is, wrap it up, throw it in. So maybe we'll open up a couple of those after we get through collections. I think that'd be fun. Speaking of cob, our nodosaur, this is a bone you can actually see. So this is the tibia. I'm gonna say at least most of a tibia. So it's in mud that's very slick and slided. And what that means is that the mud shifted around a lot, especially just after the animal was buried. So this part of the tibia actually needs to move over here. This needs to move like this. It was sheared in this direction. And there are a bunch of scattered pieces next to it that I've put together. And this is gonna end up going somewhere over here. These are the kind of projects you get to do. You get to do puzzles. You get to open up big limb jackets when you volunteer here. I have some tools and equipment and chemicals I thought I'd go through. This is what you can expect to find in a fossil prep lab. You ever wonder what that putty is on fossils? We use Apoxy Sculpt. That's a taxidermist sculpting compound. We like to be thrifty here, I would say. So this is Gypsona. These are plaster bandages that doctors will use to make casts, and they have a lot of uses, actually. But these are from the 70s. Denver found an eBay listing that was nice and cheap, but Gypsona from the 70s, no different than Gypsona from today. Nice expired laxative. Sometimes I keep this on the front counter. We have windows in the lab and guests can see what we're doing. So why do we have wax in the lab? So the brand here is Clearlax. That doesn't matter to me. It's a compound called polyethylene glycol, also known as carbo wax in our field. It melts like a wax, and we do it in things like this wax cup here. We put it on a laboratory heater, and you can see the solidified wax in there. It behaves just like candle wax in every way except for one, and that's it melts in water. So we can apply it to a bone. It surrounds the bone. It's tough. We'll use either cheesecloth or a method Deanna just started using, this sieving mesh embedded in the liquid wax to strengthen it. And then when we're done, we just apply water. The fossils don't care about water, and wick it away. It's one fun thing we do. We're opening jackets. We use these cast cutter saws. Some people use angle grinders, and I won't lie, sometimes the jacket is big enough where you just need an angle grinder, but very dangerous angle grinders. These, you put your hands on it even when it's running, and it doesn't do anything. It's a very safe way to open up a plaster jacket like this one. There's always room for demonstrations if we have time later. Air scribes. So these are a preparator's best tool. Not the only tool, but I'd say the best tool. So when they're attached to an airline, air goes through and the tips reciprocate. And we try to find an air scribe that is both gentle enough to do the job, but also reciprocates in a way that it meets the resonant frequency of the rock and breaks it apart. We talked about Jack's Bone Bed. This is another active volunteer project. This is a case of something like we thought this could be cool. We thought it was a nasal or the nose bone of a duckbill dinosaur. And the nasals are very informative. So Liz, being an expert in these things, we contacted her and she said, nope, that's the back of an ilium, which makes it a little less exciting, but hey, it's the back of a hip bone. So what are you gonna do? We learn every day. One cool thing we have here is this. So I said ceratopsian bones are rare in Jack's Bone Bed. This is one right here. This is a jaw, maxilla, so that's an upper jaw, with a piece of a tooth still embedded in it. So it would have had rows and rows of teeth slotted into these alveoli, we call them. And this is just the token, you have to show it off, Tyrannosaur tooth. So this is a Daspletosaurus tooth, also from Jack's bone bed. We find hundreds of these. They're very common. Tyrannosaurs shed them like bullets. I don't know if you can see the serrations there, those square serrations that keys you in to the fact that this is Tyrannosaur, large Tyrannosaur. And rounding off the back of the front counter here, we have another cob, another nodosaur element. In this case, we have a mid-dorsal, so one of the middle vertebrae from the back. It's kind of unique because the zygapophyses right here are fused up and are kind of cup-shaped. Usually they're separate in other taxa. And look at this really slender neural spine. If you're a dino geek, you'll understand it's really narrow, and that's one of the telling signs that this is from a nodosaur. We found many this year, and this is the first vertebra that's fully prepared, and that was done as of a week ago. So all of this is stuff that's actively being worked on, not a month ago or 2 months ago or anything like that. I think we should also go back to Denver's Tyranno. So we have showcased this in the past. Every year we have some more work done on the block. This kind of work is very, it really works on your wrists. It really works on your body in different ways. I have to crane my neck in all sorts of positions to work on the block, which means maybe a day or two a week I end up working on this. It's really, really tough. This is harder than concrete. We've confirmed this is harder than concrete. Our air scribes that we use to go through this, they'll go through concrete like butter, but not this stuff. There's one over there. I'll walk around and grab it. So we originally started by using a prototype of this air scribe. This is called the Zoic Bronto. We have a really good relationship with Zoic Paleotech, which is a company that makes air scribes in the UK. The first one they made, they sent one of them to us, and we tested it out on this block, and it was perfect. So now it's a production model. This is one of the production models, but we were happy to prototype some of their air scribes. This is the tool that actually does the bulk chewing through this really, really tough matrix. And then when we get closer to the bone, we use smaller and smaller, finer air scribes. So I also need to demonstrate this monster here. So this is not one brand of microscope. This is a combination of many different brands of microscope part and also some custom fabricated parts made by scientists we work with named Mike Eklund and myself. This is mostly of Mike's design, but him and I collaborate on microscopy, trying to find ways to take ergonomic parts like this and add them to things that wouldn't otherwise accommodate them. For example, this whole monstrosity up front here is a Swiss scope called a Leica. It is mounted to a Nikon that we had to machine, a Nikon focuser, I should say here, that we had to machine from scratch. This is the kind of stuff going on here at Dickinson that I think maybe not many folks are attuned to. I might as well show you what it looks like when I'm actually working on this. So my shoes tend to feel heavy when I go up on here. So I have these old Birkenstocks I can slip on so I can be comfortable when I actually step on the block. And I do it just like this. I'm literally laying on top of this thing when I'm working. And this is being streamed to a lot of places. People who watch me on either YouTube or Twitch, pretty soon you're going to see this happening on Twitch. What's in front of me right now are a few ribs that are all articulated in place. And I see I have a camera here that can get me an angle on those. These are all new from a year ago. So Dion and I have got all of these ribs out. So we're happy that things are in place. There's one rack of ribs here, and there's actually another rack of ribs from the left side of the animal showing right there. So I'm in the middle of a rib cage that's splayed open, and we have back vertebrae that are gonna move through here. The first three are showing right where I'm pointing there. And so why have this big cumbersome microscope? One big common question, well, we're not using the microscope when we're doing the bulk work of getting the rock down to the bone. But once we've identified that a bone is about to be discovered, we have to switch instantly to a microscope. We can't just use a microscope on a fixed stand or even a boom like this. It's not long enough to get to the middle. We need a really long arm to get us to the middle, but we also need a lot of magnification. So this is a special scope that can give me 100 magnification, and it has a long working distance, so I can keep it far away from the fossil. I don't have to jam it right into the fossil. And we have lots of different lights on this, radius lights, ring lights. We need all the light we can get, all the light we can get. And I can stream this to you. I can stream what I'm doing under the microscope to you or to a television outside. I have this up here, if you can get an image of that. So this is the view on my monitor right now, but that will be coming to a stream near you. Let me make sure everything is in focus first. That would be nice, wouldn't it?
And when the lab expansion is added, we'll be able to stream this to the TV outside of the lab, and people will be able to see the close-up as well as looking through the windows.
Yeah, so now we have some stuff in focus. So this is the tip of one of the ribs. And what happens sometimes is we're doing some bulk matrix removal, is what we call that, powerful work with the big tool, and we'll chip into the tip of a bone. And that's more or less to be expected. So there was a little bit of bone here that went AWOL, I'll say, because we hit it with a tool. We had no reason to believe it would be there, but as soon as we do, boom, we switch to a microscope and we get it out carefully, the way it's meant to be worked out. That's not everything there is to this apparatus, but I think that's what you'd be most curious about. And of course, we do have more standard microscopes we use when we can. But this unit is one of only, I think, 4 or 5 that exist in North America or anywhere else. There are only a few projects of this scale and importance. This is potentially one of the most complete large tyrannosaurs in the world. We're moving toward the area. We have a skull. We find that skull, I think we're there. One of the most complete tyrannosaurs, if not the most complete large tyrannosaur.
What's next? You want to look at the bones?
Yeah, in terms of lab stuff, I think people who have watched me on Twitch could get a kick out of the air abrasive station here. So I'm not always able to stand up and show you what it actually looks like. Here in our lab, we have micro abrasives. We have Swan Blaster, just like I've talked about in the past. And this lets you see the acrylic protection that goes in front of the microscope and separates the fossil from all the delicate mechanical parts. And we, of course, have holes for our arms, and we have dust extraction that's vented out the back. But most recently, Diana's worked on a couple really cool bones using microabrasive techniques at the center of everything. So just last week, this pterosaur wing bone, we're thinking second digit, on this?
Yeah, this is the one that I was talking about. Is it from a different pterosaur? So this is one of the last finger bones of the wing that is made of the finger. It's really big compared to what we might expect based on the other pterosaur bones. So it might be from a different individual, I'm not sure. But either way, it's a big pterosaur wing bone. It's really delicate. It looks a bit crushed. It's actually less crushed than it appears. One of the nice things about these bones is they're actually three-dimensionally preserved pretty much. They're not too badly crushed. And Deanna's done a wonderful job of cleaning them up.
So you saw the bottom of this. This one's, the bottom still isn't abraded, but we feel there's a risk. You can't just hold a bone like this and abrade it. It's going to fall to pieces. These things, you can add as much consolidant or glue as you want. If they're this slender, they still want to fall apart. So we're waiting on an order of a compound called cyclododecane, which I can talk about a little more later, or another stream, that is a wax-like substance like the carbowax, the laxative I showed earlier, except you don't need water to remove it. It sublimates. So that means you add it, you add several layers. As the days tick by, it just disappears into the air, which means a clock is started as soon as you add it. You've set yourself a deadline to finish the project. But I'm not comfortable painting this with water because just the force of the brush might want to break it. So this one, the other side, is slated for that cyclododecane. And I think Denver is excited about this other bone here, if you want to explain this ilium.
Yeah, so this is from the Oviraptorosaur, the caenagnathed. So this is the hip. So this was pretty obviously a hip when we found it in the field. This is a little bit that's broken off and shifted before it was fossilized. And this is the hip socket where the femur head would go in. So it's not quite right for the Troodontid. So this is one of the first indications that we had another small theropod, or relatively small theropod, coming out of this site. Again, preservation is wonderful. You can see here these little sockets here, if you like. These are where the sacral ribs, so the sacrum is all the fused vertebrae. This is where the sacral ribs attach to the ilium, the hip socket. So this is one of those bones from the Oviraptorid that we've been collecting. It's every day we get to see new bones from these fragile animals. It's just we don't necessarily know which one of these skeletons they're going to belong to until they're clean, and even then we've still got to start. A lot of the toe bones look very similar, for example.
Like, we're very careful in the field. If something this slender is sticking out, we don't want to expose anything unnecessary in the field. We try to leave all the matrix or all the rock on top. So we let the lab, the preparators, get it out and figure it out using really refined techniques. We got a question: do we keep a digital catalog of everything? Yes, we do, absolutely. Redundancy is really important as well. We always have multiple labels. This is a field label. It just shows the date, who collected it, what it might be, a field number, and whatever was in the jacket. And then after it's prepared, these are about to migrate to collections. Collections will assign them a label and an accession number. And so all of these labels are carried on into collections or the exhibit, and of course are added to a digital catalog that is constantly updated by the collections manager.
Do you want to see what Liz has got over here?
Let's go see what Liz has.
Welcome. So we're moving towards collections, but we've laid out a few things here. So this is the fossil that I was most excited about this summer because it's part of a skull. And it may not look like much right now, but Denver mentioned it in the field presentation, the PowerPoint part, and he showed some pictures. So what we're looking at now is the bottom of the brain case. So I'll flip it up so we can see the top side. So this is the forehead of the animal, and the eyes would be here. So there's the eye socket. there, and then this is the back of the skull. So this is a duckbill dinosaur. This is different than the Lambeosaurus that we had on the other side of the hill, full, complete, articulated Lambeosaurus. And then on the side of the main bone bed with all the raptor bones and the pterosaur bones and everything else, there's this big hadrosaur that we've got a lot of the legs and the arms and the pelvis, and we finally got another part of the skull. We also have one of the jaws, and they're both huge. This is gigantic. So the span across the eyes from eye to eye there, this is a big individual. This is a really big duckbill here. So this part of the skull is missing on this side. It got eroded back in the Cretaceous, but that's how big it would be. So we're missing a part there. And so the brain case is good because this is where the top of the skull is, and if it had a crest, we would often see that here. So this is how we know that it's not a Lambeosaurus, that this is one of the more flat-headed hadrosaur dinosaurs, and it's probably a Gryposaurus, which is a genus I've worked a lot with before. So we go back to the bottom side of it. The reason we call this a brain case is because this is where the brain is, and so you can actually see the holes of where the brain was. So part of the bottom bone is missing here, but this is the foramen magnum. So this is where the spinal cord exits the brain and goes down to the vertebrae. And all along the sides, there's lots of other little holes. There's a big hole there, there's a big hole in the front, and these are where the cranial nerves come out. So this is where nerves come directly out of the brain and serve various parts of the head, mostly. And what's really cool about cranial nerves is that we all have the exact same ones. So dinosaurs, sharks, humans, we all have the same 12 cranial nerves. So this is going to be really cool to study the brains of these dinosaurs and learn a bit more about their different senses, their levels of intelligence. So we're definitely going to be CT scanning that in the future. And then I pulled this over from the lab. Steve was just showing you this out in the lab, that this is part of the skull bone of a juvenile hadrosaur. So I thought the size comparison here is pretty cool. So we're looking at the same bone here and here. And so there's the foramen magnum on the little juvenile versus that. So you can kind of see the difference in size between these two individuals. So it's just a really cool bone bed that we have multiple different species of duckbills, but then also all sorts of different ontogenetic sizes. And then we also brought out one of the many other things from the bone bed. This is an ankylosaur scute, just beautiful texturing on it. So you can see all the little pock marks. There's a nice depression here. This is a little articular surface where the next scute would attach. So just lots of fun little things. I'm going to show one of the collections cabinets now.
Can do. I got the brain
Come
case and the hand here. So these are in the
Ooh.
talk.
All right. If you like raptors.
So I talked about, so we just saw a brain case, so a good place to start. This is the troodontid brain case that was prepped by Deanna a little while ago. So I actually have this 3D print of a troodontid skull. So you can see this is the area here that you're looking at. It's actually basically the same as the 3D printed one. Almost the same size, actually. It's a little bit smaller, I think. This is a troodontid from Mongolia, I think, called Zanabazar. Yeah, this was... We didn't know what this was when it was found because we don't expose the bone. We could see it was dark brown, glassy bone and fragile. So we very carefully work around it. And then when it's getting prepped in the lab, we figure out what it is. This was pretty obvious that it was a brain case quite quickly. There are not many brain cases like this that have been found. I think there's one or two in Canada, and there might be one from western Montana, and that's about it for North America. Here we've got, this is that wrist or the hand. So this is the Oviraptorid. The bone tends to be a little more yellowy than the troodontid. The pterosaur can be this yellowy as well sometimes. Some of that's weathering, but the color and how much it crushes is actually fairly informative, a clue to begin with. But this is the palm of the hand and this is the wrist. So if this was on me, it would be like that. and a very similar size to my hand, I guess. So this is from the Oviraptorid, and this funny little half moon-shaped bone at the top here, that is the semilunate carpal. If I turn it around, you can see it's got these ridges. It's kind of, it's a weird twisted shape, which is what causes the wing to fold up when this animal flexes its wrist. But the fact that this is articulated still is really amazing. Don't know where the other one is. There should be another metacarpal to go with it. That presumably floated off, and we might find it in another jacket or something. But I couldn't tell you how many Caenagnathed articulated hands there have been found in North America. I suspect that might be the only one. If not, there might be another one, but there's not many.
Obviously, we're live here. We get some questions. Somebody's asking, in Jurassic Park 3, somebody blew into a little endocast looking thing and it made sound. Is that something that's real, or is that movie magic? I believe they're referring to like the resonating chamber of a raptor that was printed. I know it might be possible with crested hadrosaurs, but is it possible in something like a raptor?
You would assume that these animals were capable of making sound. So the question would be, what kinds of sound? Will there be complicated sounds? And the resonating chamber is what adds. I don't know that much about how these things work, but birds, the complexity of the sounds is in the throat, right?
Yeah. So raptors, there's not really so much of a resonating chamber. That is much more of a hadrosaur thing. With the big crested hadrosaurs, we know the nasal passages were quite complex, and that probably affected the sounds they could make. Ankylosaurs also had some complex things going on in the nose, and that may have affected their sounds as well. But as far as theropods, it's probably mostly in the throat like it is for birds. So yeah, that was kind of a speculative part. But also really cool early 3D printing when you think about the fact that that came out in 2001. And now we 3D print constantly, but that was really cutting edge then. We've got more raptors in the drawers, or...
Yeah, we can look in the drawer. If anyone has requests of the sorts of things they want to see, we can start pulling different things out of different drawers.
Yeah, we're keeping an eye on the streams. We're on YouTube and Facebook and Twitch, so feel free to send questions.
A lot of our things that are waiting to be catalogued that have been cleaned are in these drawers. So this is one of those pterosaur neck vertebrae. The others are next door because they've had their numbers put on them. This one hasn't had a number yet because Amanda broke her leg. But yeah, this is one of those pterosaur vertebrae, and it's really exquisitely preserved and exquisitely prepared. Just a fantastic specimen. And we're lucky. People say they look like a teddy bear. I'm not sure if it looks like a teddy bear, but
I think so.
Maybe
Okay.
more so in Pteranodon.
A teddygram.
yeah, the Teddy Graham. But one of these people get excited about. When we found the first one, people were excited. But now we have 3 of them, part of the same neck, which is pretty amazing. Here's a... I'll just lift the bone out. The bone is fine. So this is a toe bone, probably from the middle toe of the foot. I'm thinking this is from the Oviraptorid, or the Oviraptorosaur, I should say. Similar preservation, kind of yellowy. It crushes in a bit more than the toe bones of some of the other theropods that we get. It's about the right size. So this is kind of the questions that we have, because we'll find a nice toe bone like this, but which one of these funny little animals did it come from? And we've basically got to get the books out and figure out what it looks the most like. Sometimes when you're at a site, you've only got one skeleton, so you find a toe bone, you're like, yes, it belongs to that skeleton, the only one coming out from the site. But at this site, we've literally got 5 different, never mind all the turtles and crocodiles and other things coming out of here. It could be literally anything at all. So we have quite a lot of work to do to identify these things.
I just wanted to show off another baby hadrosaur. So this is the same bone I was talking about earlier when I compared it to the adult brain case and showed the small one. This is another supraoccipital. And so this is the foramen magnum where the spinal cord comes out. So we have at least 2 of very small juvenile hadrosaurs in there. We've got some jaws over in the other collections room as well. Just love the little cute guys, of course. I also love that rib right there. That is gorgeous.
Here's another toe bone. Another toe bone of one of these small theropods. I didn't feature this in the talk. We have probably a good half dozen, if not more, of these. Now, of course, you have lots of toe bones in your foot, but we've got to sit down and figure out which ones belong to which skeleton, because there's so many of them. You want to say something, Steve?
Yeah, so Danny is wondering, just from our Twitch stream, that's Danny Anduza, one of our colleagues, about how many of these fossils were prepped by Diana using crowd funds raised back in February. Viewers should be proud of that.
Yeah, absolutely. Diana was paid from the throne donations. That would have been September, I think, the work that she was doing in September. Which bones were prepped in September? Maybe that pterosaur, actually, because that pterosaur vertebra was prepped before the most recent grant kicked in, so that would have been from those throne funds. Certainly that one, and a number of the other fragile bones that we've seen. And we really appreciate that. Like, that was... It was a lifeline keeping Deanna busy, and it's a fossil production line for me. I love seeing all these things. Every day there's something new to see, even if it's just another inch of the bone.
She had also in September done the she did the Gryposaurus brain case. That
Yeah,
okay.
the brain case I was very pleased with.
Yeah.
Yeah, that came out fantastic. And these really delicate bones, I'm amazed that Deanna's able to prepare them because they're so fragile. Roughly how many days would one of these small bones take you?
Little small ones? I mean, if they're in a regular, like a small sort of jacket, then like 2 to 3 days maybe. But if it's in a microsite bag and it's just wrapped up in foil, then half a day. I mean, maybe a little bit longer depending on what kind of matrix is there, but it's Jack's bone bed is usually really soft matrix, so I just need a small air scribe and a little bit of consolidation.
Yeah,
A couple
so
days.
5 to 20 hours of work funding cleans each of these bones, and they're just gorgeous.
Yeah, we're very fortunate. It's what else? Pick something. I mean, in these drawers, these are the fossils that have been prepared recently, but they haven't been catalogued yet because Amanda's broken her leg. So we have quite a few of these, and that's why they haven't got their labels fully
I
on
also
them
just
yet.
love little tail vertebrae.
So this is a timely question.
Huge.
So you guys just cut up a chunk of Bertha for histology. When will we know the results of the study?
Okay, fair question. I've got the pieces actually in my office at the moment. Well, we're not doing that study, so I'm told that study is coming out soon. I don't know quite what that means, but I'm guessing in the next few months, presumably.
Yeah, that research is coming out in the next couple of months. That paper is in the process. So we will definitely broadcast that when it gets published. It's going to be very cool. And the files are huge. We downloaded, like 400 gigabytes of data from that.
Yeah, and we have some plans to do a really unique exhibit around those files as well on histology, but done, I think, in a way that hasn't been done before. So, you know, we've got plans for the new exhibit that is really going to do things that haven't been done before. We've got lots of ideas. IT, who are here doing all the filming and the production, but they're going to help us out making some tech kind of based exhibits as well. So we've got some really good ideas for different things we can do. There's the bottom drawer as well.
There's a couple of great little crocodile pieces in here. This is one from this summer, I believe. So this is the back of a lower jaw. This is a dentary. And so you can see the tooth sockets. And then other bones of the lower jaw, they slot back here. And it's just got beautiful texture and lovely little grooves for the blood vessels and nerves. On the outside, this is how you know something's crocodile. You see this beautiful pitted texture like this, you know it's crocodile. So that's lower jaw. And so that one's all cleaned up and ready to move to collections. This little piece is not quite finished yet, needs a little more fine prep under a microscope, but this is from the front of a snout. So again, you can see the tooth holes. And so this is a right premaxilla. So that's the front of the nose, so his whole nose would be about 1.5 inches wide. Really tiny little crocodile.
And those ones are from Elydiasuchus. So that's a more sort of long-snouted crocodile. If you watched our stream from last year, you'll have seen a short-snouted crocodile that we collected in Alberta Champsa, and only the second skull ever found of one of those. And there's some slight differences at the front of the snout to do with the tooth spacing. So when we find bones like those jaws, we can tell what species they belong to.
So another pertinent question here. Do you work with geologists to date the stuff you find? What type of testing is required?
Very
Well,
tiny.
we are
That sounds like a
geologists,
loaded
number one.
question to me. Well, we do radiometric dating, and we have some. So what that is when a volcano erupts in the past, the molten lava spews out the volcano, and often in the form of ash, and then it freezes effectively. It turns into ash or rock. And you can look at the minerals that are in that ash and look for radioactive decay within those minerals to determine how long ago the volcano erupted. So North America was volcanically active in the late Cretaceous period when these dinosaurs were living here in North America. So we can look for layers of ash and send them to a laboratory and get them dated. And we actually have some ashes being dated at the moment by one of the laboratories at Princeton. Although they probably haven't received the samples yet, but it's on its way.
Yep.
So we are working with people to radiometrically date these layers. I actually work quite a lot on the stratigraphy of these rocks, which is more the sort of physical properties that the rocks have and how those rocks line up with other units in Canada, which is very close, but also as far south as Mexico and New Mexico. And we can use ash dates to do that, but we can also use biostratigraphy. We can look for the same species of animals living in at the same time in different parts of the country. And we're using that, we're able to actually link up these rocks with Canadian units about 100 or 200 miles north of where we are. And the Jack's Bone Bed site that I was talking about, we will hypothesize that is equivalent to the middle of the Dinosaur Park Formation in Canada because of some of the species that we get in it are only known from the middle of the Dinosaur Park Formation in Canada. Some of the radiometric dates that we'll be producing will hopefully test that hypothesis or support it. What is that?
I know, I was wondering if you'd ever decided what
No.
this bone is. Beautiful bone, but very, very thin on the ends. You can see how narrow and flat both ends are. So initially we were thinking radius, but given how flat both ends are, we could be looking at a fibula or a very strange pubis. So we have mysteries. Like there are so many different animals in this bone bed that we can't immediately identify all of them. So that's why we bring in experts in other types of dinosaurs and other fossil organisms. And sometimes this triggers someone else's memory.
And that's a good bone.
It's a
Like,
beautiful bone. It should be very identifiable.
often
but
you'll have a fragment, but this
Yeah.
thing's got a lot of shape. It's got a big like muscle ridge here. It's got
Yeah.
different textures. If I knew, it's not something from something I know about, because I expect I would have
yeah,
seen it
but the
before,
ends are so simple.
yeah,
You know, there's not big condyles and diagnostic features.
it's a
So
big animal
I
though.
don't know, mystery bone.
That one there is the radius of the Oviraptorid.
Yeah.
So that one was prepared quite recently. We think it's a radius from
Yeah.
the Oviraptorosaur, the Caenignathed. God, that was prepared, 2 weeks ago?
Yeah.
Maybe? Wasn't long ago.
Very recent. There's new stuff every day.
Yeah.
I'm over at the university, so I get text messages all throughout the day of pictures as these are being cleaned up.
Yeah, and some of the pictures that are in the talk will have been those little quick ones that I sent to Liz.
Yeah, exactly. This is one of the things that was
Oh.
in the talk. So this is that little juvenile femur. So it's missing about that much. There's a big muscle attachment there for one of the leg muscles. We have the two condyles at the bottom, so that's where the knee joint is located. So this would be a cute little animal, bigger than a cat, but what size dog?
I don't know. I said it'd be
Yeah.
about a meter or so long.
Yeah.
It's after the nest.
Yeah, smaller than a golden retriever, but bigger than a cat.
So a great group question for us.
Yeah.
Is there a taxon that we have not come across that we want to find? Anything in particular that we're saying, I really, really want X, Y, or Z?
I think I've gotten most of the things I want because we have a variety of different hadrosaurs. Denver, of course, wants more ceratopsians, so we've got some ceratopsian material, some horned dinosaur material, but not a huge amount of that in the bone bed. And as you said in the talk, there's also not a huge amount of tyrannosaur material. And so that is weird why we're getting so many of the super fragile little raptor dinosaurs and so many of the super fragile pterosaurs, but not the big bulky tyrannosaurs.
But we just found that splenule.
Well, yeah, there's pieces, but not that many. That's
Yeah, I mean,
unusual.
we haven't cleared that much of the bone bed yet
Right.
either. I mean, there's a lot to go. I'll show you the little horn since I'm here. If I can just
Yeah,
get
exactly.
It's in the next one up. I'm proud of the gluing job or the puzzling job I did on this one. Here we go. So this is that little horn, Chowl's horn. So Chalfant found this, and here's the eye hole, and there's the little horn. So in these centrosaurs, they don't have particularly big horns anyway, but they start out quite small, and in this species, they never really get that much bigger, and then they basically erode away in the adults and just become a big lump or a boss. There is one little piece of frill that goes about here, so there's more than one bone at this site, but it's small. And that's the key piece. I was so pleased with this piece because we had this big lump here and we had these back lumps, but I couldn't get them to click. I'm like, we must be missing a bit. So we collected, I've got a bag of chunks, like 100, 200 chunks. And I tried them all out and I found that one. I wish we had this bit, but you know what fits there. That's not too much of a problem. But this was really good because it told us how long this bone was. So this is just a little guy. Probably a Centrosaurus brinkmanni because this is from part of the Judith River Formation, which is equivalent to the Upper Oldman Formation. So it's not Dinosaur Park equivalent, this one. It's from a little bit lower. It's from a new area where we were looking for fossils on the Bureau of Reclamation. Love that little guy. What else might we want to see? Do we have any requests?
Yeah, any special requests on Twitch?
Before that, I thought it would be timely. Filippo's paper came out recently.
Oh,
We
yeah.
have had
Absolutely.
enough right here.
This is Liz's specialty. I'll get out of the way.
This was another fun puzzle job. So this is a specimen that it was found one year, and the person who found it, actually Jack of Jack's Bone Bed, walked right by it because it didn't look very interesting. And then the next year, I went back with another group of people, and yeah, it was a lot of fragments lying around, but we noticed that the fragments were pathologic. They had damage to them. And so we collected all the fragments, and so each one of these came out in a gallon Ziploc of pieces that then we puzzled together the entire thing. So some of these were in 20 different pieces, and we've puzzled it all back together. And so what they should look like, what a nice, normal, healthy one should look like, is a little more like this one from back here. Well, even this one's a little messed up, but this is the spine. So you've got your tail vertebrae coming back, and then the spines that are the bumps along the back. And they should be fairly smooth. And yet, these guys, get that one back. You can see how gnarly these start looking. That we have these really strange lumps on a lot of them. Okay. So this is indication of damage. So they were fractured in life, and then this is the healing process. So when you break a bone, if you don't have a doctor set it properly, it's going to heal in a really gnarly way with a lot of overgrowth. So this strange bumpy texture that we see is part of the normal healing process of bone. But what's really amazing about this specimen is that so many of them are damaged, and these are the worst ones. This one here has a very special kind of damage. So a lot of them might have just been bumped from the side. So like maybe the duckbill is lying down and another member of the herd comes along while he's sleeping and trips over his tail. But this one, you can see the bone has split. So this piece of bone up here should have been higher up, and it got hit from above and split and wedged down onto the rest of the spine. And so that kind of splitting and shoving, that can only happen if the impact comes directly from above. And so we have this as well as another specimen that's on exhibit, Warwick's duck, that show this exact same really bad pathology. And these are two of the three best worst specimens in the entire world. So Filippo Bertozzo, as a PhD student, came over and looked at these. And the only way you can get this kind of splitting action is if the pressure comes right from above. And so he went all around the world looking at hadrosaur tails. And the damage that you see in the tails, it's really common. This is, one of the worst examples, but it's really common, and it always happens right behind the pelvis. So what can get you repeated injuries where a heavy weight is coming and causing an impact from directly on top or right behind the pelvis? So these are mating injuries. So we're presuming that anyone with these injuries was a female dinosaur. So yeah, just really painful looking injuries there, but very cool. And so that research paper came out recently, and it's open access. We can provide a link to that so people can read the paper afterwards.
And sort of leaning on that, there's a question. I can answer the first part. Yes, we do find a lot of plant fossils.
Yep.
We find a lot of plant fossils. And we could show you at some point some of those leaves, seeds, all of that. But specifically, what might Haddonuf have been eating?
Well, plants in the vicinity, based on the leaves and the seeds, we knew there were fairly similar deciduous trees to what we had today. So there's like some poplars, fig trees, a lot of conifers. They were probably enjoying a lot of conifers. Haven't found any cycad fossils, but they might have been in the area. So yeah, we're just starting to get into a lot of deciduous flowering trees, and those were probably pretty tasty leaves. But I imagine a lot of conifers, probably. Yeah.
From Jack's bone bed, so the
bringing
one that
some
we've been
seeds?
talking about a lot. No, this is all amber.
Ah, yes.
So whenever we find little pieces of amber, this is actually quite a big piece of amber. We collect it if it's not obliterated itself. So all these little pieces of amber. There's some bigger pieces in here as well. There may be insects in these. There's a really, really big piece. So of course amber is fossilized tree resin, tree sap, and sometimes you get little insects and things in it. So in the past we've sent these samples up to Saskatchewan. Ryan McKellar is there, and he's one of the, well, if not the world expert, certainly on North American amber and insects and things that you can get in it. And even the small pieces without insects in, you can find air bubbles, bits of fungus and bacteria and all kinds of things in it. So going back to the question about the leaves, I just put all the leaves away the other day. I've been unpacking various different fossils, and we have a big sample of leaves from the same bone bed, Jack's bone bed. Actually, the layer just above it. And so I've been putting those in a drawer. And we keep the nicest ones. And there's lots of seeds and things as well from that.
Yes, we found a lot of seeds, a lot of amber, and lots of leaves. So we get two layers of leaves. We have leaves within the bone bed with the bones, and those ones are really cool but very hard to collect because this being a river channel, the sand is being deposited kind of in waves. And so the leaves that we find amongst the bones are often curled, which is fascinating to see that this is like a three-dimensionally curled leaf in the sand, but trying to collect that is extremely difficult. But the really nice leaves we get are just above where the bones are, just above that. We have a very nice flat-bedded, laminated, more of a mudstone that comes off in beautiful sheets, and that is great for some leaves. So we have lovely huge leaves. Some of them look like lily pads. I don't know if they are, but they look like lily pads.
We jacketed.
We jacketed,
You
yes.
and I jacketed a
Yes,
big.
we jacketed a big
the
pile
first
of lily
plant I ever
pads, and you have
jacketed.
not cleaned it yet.
No, I haven't gotten to that. Jumping off of that, so is there any direct evidence of a duckbill having consumed something? Have we found plants in stomach contents, anything
There
like
are
that?
some hadrosaur mummies. So there are some preserved with skin and presumably the gut region intact. And people have done some analysis on the pollen and plant fragments that they find in there. But of course, it's really hard to tell if that's original. Like, are those truly stomach contents, or is that something that the river washed into a stomach as it was rotting out? But what we find in those stomachs is pretty similar to the leaves and pollen that we find everywhere else.
I'm doubtful that any of the mummies that we've got have got the guts preserved.
Yeah, definitely not. They're too separated.
We have the Lambeosaurus that has extensive skin impressions, but that one, the right-hand side of the animal has skin impressions, but the left-hand side is all moved, so it was probably sort of only half preserved. That Brachylophosaur with the skin impressions from last year, that one's hopeful maybe.
Oh, Dendok?
Yeah, Denduck.
Yeah.
Oh, the concreted one. Yes, if they're in a concretion, you have a better chance of things being preserved in
We
3
haven't dug
dimensions.
into that, though.
But as Steve knows on the Tyrannosaur, cleaning something in a concretion takes years.
Yeah, that
Yeah.
one's a
Try
challenge
not
waiting
to.
for someone else.
I won't mind if we don't find a helicopter for that. I won't
Yeah.
mind.
Well, the problem with that one is you could drag it up the hill with a tractor. It's gettable. That's
Forget about the tractor.
it'll be a problem for the future when we have the space, and we'll have to start to think about it then. That's part of that actually fell down this year. Part of the tail actually fell down. First time I've seen it move.
Yeah, I saw
Well, it didn't
that.
move, but it came down last winter presumably. So,
More questions?
questions or requests? Taxon requests? There's that tooth-marked frontal in there with the like.
Oh, which shore is that in?
Put that one away. It's in the Jack's bone bed stuff. Mostly Jack's bone bed. It's in one of these. There it is.
Oh.
So this one's quite abraded. It's a bit. Here, you can point out what's on it because
Yeah.
you're the
So
expert.
yeah, it's another hadrosaur. So this one has really tumbled down the river quite a lot. You can see how all the edges of it are very rounded. So this is not something fresh and pristine like many of these fragile bones. This is really durable, and so this is basically a big pebble that rolled down the river for a long time. And so that was the brain case area on the bottom side. So that's part of his brain sits in there. And then this is the forehead region, and you can see these really nasty gouges right there. And so these are old. They probably did not happen as it was tumbling down a river. These probably are bite marks, and they're large enough. It's presumably a tyrannosaur that was digging into the brain of this poor, unfortunate hadrosaur, who was just a little teenager. He was not full grown, but delicious. So,
brains.
brains.
So, Danny, if it's not too off topic, would like to see Danny Ceratops again.
Okay, that's in my office. This is a specimen on loan from Museum of the Rockies, and I'm busy writing it up. There's not that much of it, but what there is of it is important. So this is the oldest, probably the oldest Chasmosaurine that's been collected from North America. And this goes the other way around. This is, I think this was the first thing that Danny found. The sort of the whitish parts is what was exposed. So this is what was sticking out of the rock. And yeah, Danny comes up to me and says, "I found a Ceratopsian skull." I'm like, "No, you haven't." But he had. So, and it's got a complete squamosal, and it also has, this looks like it's a kind of boring bit of rib or something, but it's actually part of the middle of the frill called the parietal. And I presented on this at SVP a number of years ago, which is why I have to get the paper finished. but it shows that this looks more like the young chasmosaurines from about another 1,000,000 or 2,000,000 years later, which is a pattern that we see quite commonly in dinosaurs, that the young ones can look like the ancestors for certain features. And this one is one of the oldest chasmosaurines in North America. So there's not that much of it. There's a few other fragments that were collected. This is the cheek spike. There's the cheek spike here. It's not particularly diagnostic in itself, the cheek spike, but it's a nice part to have because it gives the animal more of a face. But that's what there is, a Denny ceratops. Danny found that a number of years ago, and it should really be a new species. There have been other ceratopsians collected from these horizons, but they're mostly from fragments, and I think many of them have been pieced together or incorrectly restored. So I think that this is the most complete diagnostic specimen, certainly of a chasmosaur, from those horizons. But yes, I should get it finished. But that's Danny ceratops, named after Danny Anduza, who was my field assistant when we were collecting up in the Judith River back in 2014, maybe, something like that. Maybe earlier than that, 2011 actually, I think.
So we have another, I think, a cool group question. So, in our opinion, what is the most scientifically important fossil or fossils in our collection? That's a hard one.
Oh, opinions will vary. There are so many. I mean, obviously, I love the pathologic I love the pathologic hadrosaur tails. Those are fantastic because they're evidence of behavior, and we have two of the best, worst ones in the world. I think that pterosaur is probably one of the rarest things, to have three-dimensionally preserved pterosaur bones and to have what's potentially an associated skeleton.
Yeah.
That's incredibly rare, and so that's going to be fascinating, especially if we can get some skull material out of the bone bed.
Oh, that'd be great.
I mean, the raptors are cool, but they're slightly more
The
common.
theropods, whatever.
Yeah. What do you think? Ceratopsians?
I like this. I like behavior. If you can do ceratopsian behavior, that's even better. So I like my Leptoceratops
Oh,
projects.
Those are cool.
We've got a site that we might be digging next summer. We'll see. That's another one of those Leptoceratops bone beds. I mean, there's quite a lot of animals that are, or specimens that are unique or very, very rare. I kind of like the tooth marks. I really like all the tooth marks. I mean, are they particularly important? Individually, no. But if you have lots and lots of tooth marks, you start to see patterns of how animals feed. If you just got one, maybe it just did something weird that day. But we have lots and lots of tooth marks that we're collecting. Something strange about the Judith River seems to be that there's a lot of tooth mark bones, and I don't really understand why.
I
But,
think we're
I'm
just
not-
looking for them. I think we have that search image now that, like, every fragment I find, I check it for tooth marks. And so I think once you have that search image, you're going to find a lot more. I also completely forgot about the Lambeosaurus skull.
Right, I mean,
oh
that
yes,
was-
the
that was
articulate,
in my
the,
mind.
the complete Lambeosaurus skull. That's one of the only ones in the world, and the only one in the U.S. that also has skin and an
Yeah,
associated
yeah.
skeleton. Yeah, we forgot about
No
that because
biggie.
that's old news. We've got other
That was
things.
a couple of years ago.
I was going to say, my heart is in the Lambeosaurus. That's where I was going. It was a fun project. It was fun, even more fun to get out, I think. But my mind goes to the pterosaur. Yeah. I think you're looking at this pterosaur as being possibly the most scientifically interesting thing.
There are
Possibly.
Tyrannosaur fans who love the Tyrannosaurs we have here.
Oh yeah, Denver's Tyranno.
We have Denver's Tyranno, the concreted one in the block. We have the holotype of Daspletosaurus wilsoni. We have the Holger specimen, which is probably another Daspletosaurus wilsoni. We have another specimen, concrete Tyranno, which is currently in storage because we have to do some cleaning on that one. It's not as complete, but it's the smallest of all of them. And then we have lots of other pieces of other Tyrannosaurs. And not to mention, down there on the ground, I don't know which camera's active right now, but that is the femur of Bertha. We're working on this new exhibit on Bertha. That one's a historical one. That's one that the Leagues collected in 1987. And we're working on the description of it. it's not correctly restored. It's actually quite a bit bigger than the way they've restored it. And we've been working with some experts on restoring these things.
Yeah. So you can probably see on the texture the difference between areas that have a little bit of texture to them and interesting modeling of color versus these ends that are just very smooth and totally brown. So these are reconstructed in plaster and have been painted. Not great. So same at the bottom end, the bottom condyles were also reconstructed. And so Denver's working with a group that is digitally reconstructing them in a much more accurate way. And they think the actual real length would have been significantly longer. So we're going to try and fix this poor restoration job and make it more scientifically accurate.
Yeah, and this will be on exhibit as part of the Bertha exhibit. It is probably one of, if not the biggest T-Rex individuals known. It is absolutely enormous. It's as big as Sue at the Field Museum. It's just that because of the missing parts on the ends, it's not totally clear how long this bone would have been. But it would have been longer than this. And it's basically in the ballpark of the very biggest T-Rex specimens. Now, of course, it's only a leg. We only have 3 limb bones, so it's obviously not quite as significant in terms of the skeleton. But when you get these limb bones, you can cut them. So we cut all 3 of these limb bones, and it will be the most histologically well-known of all the biggest T-Rexes. Better than Sue, better than Scotty, better than all of those. And people will be able to look at those histological sections and figure out for themselves how these animals grew so large. And that, of course, that's part of what's going to be in the study that's coming soon from Holly Woodward et al. I know Bertha gets a lot of attention because it's so big.
People like T-Rex.
Yeah, it's one of the best things, or one of the most scientifically important things that my predecessor Larry League collected, who was in charge of this museum and founded this museum in 1992.
So what's the benefit of cutting it and doing histology when we have micro-CT?
Micro-CT is not quite there yet. It's also hard to access, very expensive. It's getting close. There are also some other engineering tools that are getting really good at super micro scanning to look at cellular structure. It's getting there. But we don't want to wait 10 years for the technology to get there. We can cut it and really see the actual individual cells. And also, if you want to do a chemical analysis, you've got to cut it in there anyway. So we can also do things like isotope analyses within the growth rings. It's also just beautiful. But it's a process. It's a complicated process because we want to make sure to fully restore everything. So the part that we're going to slice, we mold and cast and restore it so it doesn't look like anything's missing. The bone is the same shape it always was. We haven't lost anything there. And instead, we get this amazing wealth of information from the inside. So yeah, maybe someday the tech will get there. It's in the process, but
I think histology,
it's not there yet.
It's the real thing. You can zoom in on histology with your microscope as far as good as your microscope is, the optics. You'll see the cells, maybe you'll see the atoms one day. You're not going to get that from micro-CT. And we don't know the sorts of things that we're going to be able to figure out because we've got good histology sections. Like the sort of information that's in there that we don't know about, that we haven't thought about yet, you're not going to get that from micro-CT because the data is simply not as high resolution. It is good. There's other things that you can do with that micro-CT data, but you really can't beat looking at them bone cells individually. Right. And
well, and of course, it's a trade-off based on how rare or delicate the specimen is. So, most of the time for a skull, we're probably not going to cut the real thing. We will probably go for the micro-CT method there. But for something really large and more simple and common, like a leg bone, traditional histology is going to be more economical and give you much better data. and you're not losing anything like you might be with a delicate skull. So, we use different methods in different situations, definitely.
So, do we want to try out opening a few
Yeah.
Jack's Bone Bed mystery foil packets?
Exactly.
from
So
the
I think
micro bags?
as a special treat for the people that have stuck with us through the whole thing, we're going to go do an unboxing,
I think it's
fresh
probably a
unwrapping
gotcha.
of fossils.
Like
We
a
don't know
gotcha.
what's
It's a gotcha
inside.
box.
So what year are these? Oh, 2025. Okay.
It's going to be good stuff.
Deanna, you want to get in?
Oh, great. I get to
Yeah.
Open some little micro bags.
I've been
Yeah.
doing this a lot in the last month. It's part of my therapy. Unwrapping
I'm gonna
some of
just
these.
stand
We
back
call it
here.
microsite, but it's basically just small things that were found at Jack's Bone Bed. Some of them are microfossils, very tiny microfossils.
Some of them are less microfossils.
Well, that might be something wrapped in tissue paper. Well, let's open one. We don't need to put them all out. All right, that one's got tissue paper, so there's something in there. Well, there's always something in there. It's
Very thin. Oh, God. Hello?
it'll be in there. There you go. What's that? Uh,
Hey, if
giving-
I
it's giving
added
fish skull.
paper, it's something
now you
special.
see, the problem with this is I have to get my glasses. I have like two focal.
So I
You can get
add.
the jeweler loop. It's giving fish. Fish skull, sort
Hmm.
of.
I mean, I add paper towel when it's either something really special that I want to mark so it doesn't get lost,
true.
or something fragile.
It's an interesting for a first open. Usually you go
true.
through a bunch of clams and plants first.
Or
but
chunks.
yeah.
This is shape.
Yeah,
it's got
that looks
tec- it's-
fishy. That
It's
looks
got
fishy.
texture.
Fish skull maybe,
Fish.
fish
Yeah.
cranial.
Can you show the other side?
I mean, look at the striations on that.
Is that fish or? Yeah, probably fish. Probably fish.
Probably fish.
Yeah, okay.
Okay.
All right, so the paper towel was overkill. Fish are nice.
Ooh, we got double wrapped. Okay.
This bag is just randomly picked.
Yeah,
Like-
it's just that is what we
We have
collected
a whole,
one day.
We have a whole box of them.
Yeah.
Sometimes we'll take two of them in a
Yeah,
day.
we average 1 or 2 gallons of that
Okay.
every single
okay,
day.
that's
A tyrannosaur tooth. Look at
a
that.
good
That's
second
that's a
bag
good one.
opening there. I mean, we're not lying when we say these things
is
are
cool.
all over,
It's like-
all over the place.
Seriously. They're a
They
dime
shed
a
'em
dozen.
like bullets, but that's unprepared, so it's a little more fragile.
You can see the serrations right there if you look really close.
Looking for my hand lens, but I only got this one.
Your loop.
She got a tyrannosaur tooth on the second
Oh,
pull.
this cute one.
Yeah.
Lucky dip.
It's so cute. This
It's like
one.
those Pokemon videos you get.
You mean the gambling? Because that is
When they
gambling.
open the packs of Pokemon cards, like, that's only worth $1. I've never seen one turn a profit. There's this, and this is 2025 stuff, so there's not as much.
Okay, we got a multi-part
Junk
over
in
here.
there.
So we have some questions coming in. What % of fossils do you think you're able to actually examine and do science on? It seems there's
Yeah, I'd leave that one.
This
a lot
one-
of things
That's
that are
one
just
that
so
needs
common,
careful
it's
preparation.
That
impossible
one is really
to really
No, it'll be
examine
fine.
them.
It's just that's,
dusty. I'll
you
leave
follow
that's
that?
that
something
for
delicately
later.
wrapped.
Do that later. Some things we don't pull out of the foil immediately because we recognize that it's going to need some carbo waxing for stabilization purposes.
Yes, some of the things are very delicate and should be opened very slowly.
Oh, we got our first snail.
Ooh,
It's an okay snail.
there are a lot of those in the early.
There's actually
days.
a lot of clams at this site and very few snails. But we do
It's a
save the
complete
snails when they're
snail.
good.
It's
Yeah.
cute.
Well, I got a drawer full of snails
Snail drawer.
and clams and,
And
leaves.
as much as, we're dinosaur paleontologists, we're not very interested in snails and clams. They're actually really
Keep that,
useful
keep
for the paleo environment.
'Cause
So they tell
I got a
us
system.
about that ecosystem, what was the temperature, what was the water flow
That's
like.
a question mark one. So we set that in here.
Yeah, you know,
But like that's, I have different categories of like what we're going to do with these. Like some of them are a nice little bone, a pretty robust one that can be worked on by by a not a by a new person, or not a totally new person. What's
Okay,
that then?
is that just a
Looks like a little bit of a salamander vertebra, maybe.
big block? But I guess it just came off in one bit.
Yeah.
Cool. What do you want?
Yeah, we don't need that. That
You
one
don't want
can
the
go
foil?
back there.
All right, good.
Sometimes I keep the foil because, well, sometimes there's pieces in there that we need. That one we don't. So
Are they
that is
land snails or water snails?
They are freshwater
It's
snails.
just a
Freshwater
little chunk of
snails.
Freshwater.
thing.
Yeah.
And depending on the species, it tells you if it was a lake that's
Chunk
very
of
still
thing.
water.
Chunk of thing.
It's one of my favorite kinds of things.
I like when people put on the labels either
So that one's
pterosaur or
got
useless
two
scrap of
parts.
hadrosaur. Yeah, so it's a two-parter.
Index fossils, question mark?
So they'll probably need to be
Maybe
kept
some of
together.
them
Yep.
might be.
So
The clams and snails tend not to be very useful as index fossils because
So this
they're
one's a little
very
shiny,
long-lived
which means that it's
species.
been consolidated thoroughly in the field. It was probably coming off in several pieces and was falling apart, so they wanted to consolidate it to keep it together.
So when you've got multi-part
To prevent any
pieces,
further damage, because we don't use paleobond in the field.
what is it?
I don't know. It's cute.
Okay. Well, let's put both pieces in here. So if they're single things, then I can keep them separate. But if there's two parts, put it in there so then we know both those parts go together.
Yep.
What is that?
I don't know. It's
You switch into guns. That's probably part of a crocodile or a champsosaur by the looks of it. Part of a pelvis, maybe.
maybe.
That's one that I would get one of you guys to glue together, and then we can, once it's solid enough, somebody else can work on that with a hand pick. It's a fairly simple one.
How do we distinguish land snails
This was
from
wrapped
aquatic
up
snails?
interestingly.
You get a snail
Yeah,
expert. Is
that's a
what you
Yeah,
project for
that's
somebody.
right.
It's a project.
There's a
It's
limit
small, it's thin.
to what
Wait, is that-
to what
is
any
that
of
a
us know
tendon?
about
No.
snails.
It's not just any tendon, I guess. It's
We're
got
catching some flack for smack talking invertebrates.
I'd keep those pieces.
Yep, that's
Set,
going in its own little thing.
refoil that,
Yeah.
and we'll just put it in its own little. That's fine. It'll just go in its own little pot. That's how you keep things separate.
We quickly run out of counter space.
Yeah, well, I usually have my trays set up.
Do you mean fold boxes? Snail!
Snail! Yay!
Big snail!
It is a big snail. That didn't happen.
Yeah.
Compared to the little snail.
Yeah.
What did you just find?
Snail.
A big snail.
A big
A
snail.
big snail. Look at it.
Yeah, it's a few of those.
It's almost worth giving it its own little box. Almost.
Are mammals represented in your fossil collection?
Oh boy.
Do you want to go look at a mammal?
They
Well-
absolutely are represented for sure. I mean, we have
Here. Stick.
Cenozoic
That
mammals,
and that.
which are kind of a snooze for me.
Really?
Well, do you want to see the hell pig?
Ungrateful.
Yeah, you should definitely show,
Show them the
whole thing.
entire.
Okay.
Well, we
Yeah.
have to go back in collections. I don't want to really pick it up.
Yeah. So
I picked it up
Go
earlier
for
on
it.
today.
you can have the camera follow you.
Yeah. Let's go
Yeah,
see a hell pig.
Oh boy, oh boy.
So the hell pig is here. So it's awaiting formal cataloging, but I need to figure out. So you can see the great big canines, I guess they are, in the front of the snout, and then these are the molars at the back. They actually fluoresce very strongly under ultraviolet light. If I get the UV torch, it's just in my office. I will be right back. These White River group fossils fluoresce under UV, so let's see how good the cameras are.
Oh god.
So you can see that the teeth kind of glow this yellow poster paint kind of color. And even the bone itself has a certain bluish sheen to it. And the same you'll see in this Oreodont. The teeth fluoresce this yellow color and the bone is very blue. This is Convoy C8. We've done this kind of video before, but if you look at things like casts, you can see very quickly where paint is, where this is all plastic, where the paint has missed it, that kind of thing. Even on bones that have been partly restored. Here you can see the epoxy that we use to fill in the missing gaps in the bone actually comes up very bright. And then this one has the calcite fluorescing. So I think if you ever see one of these fossils for sale, you should, well, not one of these fossils, but if you see a fossil for sale in an auction, you should get a UV light and flash it over the top and see what's real and what isn't. And they don't let you do that at these auctions, I don't think.
So I think we have a really awesome question. Is the fluorescence a biological thing, or is it like a fossilization thing? Is it diagenetic, or is it both? Why are those teeth shining like that?
It's diagenetic. It's the minerals that get into the teeth during fossilization that cause them to fluoresce so strongly. Now, there are parts of the body that will fluoresce. Famously, mammal urine fluoresces. You know, people buy these flashlights and they go around their house and they see where their cat and their dog might have had an accident. So you can do the same thing. It's the same system. I tell this to my school groups. My favorite fact about that is birds of prey flying over a field looking for little voles in the grass. People say they've got amazing eyesight, and they do, the birds of prey. But what they're looking for especially is little trails of vole urine in the grass. The voles, as they run along, they pee as they run. And the little trails that the voles leave, if the urine is fresh, it's even brighter for the birds of prey because they can see ultraviolet light. So they're looking for little urine trails, and this poor little vole, whack, gets hit by a hawk or something. So there are things that fluoresce under ultraviolet light. Mammals mostly can't see UV, but birds can see UV. It's something that they can take advantage of that we can't. There's all sorts of awesome UV stuff that's out there that we don't really know about because we can't see it.
I'll say as a preparator, some of our woes are kind of a byproduct of that fluorescence. So fluorine loves being incorporated in that calcium phosphate, we call it apatite crystal structure, which in some cases is responsible for that fluorescence, and it can also be responsible for how brittle fossils become. And I say fossil loosely because most of this is original bone material, the Cretaceous stuff you're looking at. It's just made a little more brittle by what it's taken up. So yeah, pure diagenesis is the answer to that question.
Since I'm here, I've done this before, but this is a parakeet, and all parrots fluoresce under UV. So this is a little stuffed parakeet in its natural colors, or a budgerigar, we'd call it in Britain. And all parrots and all chickadees fluoresce under UV. And they basically have extra bright patches on the face that they can see. And the males are more bright than the females. I also have some other parakeets, these ones. Interestingly, the blue form is bred that way. It's not natural, and it doesn't fluoresce in the same way. So the fluorescence is basically being bred out of them. So if you have a pet parakeet, you can shine a UV lamp on it and see it fluoresce. And I think it works for all parrots. It's a cool little trick. Like to show the kids.
So people are clearly interested in Cretaceous mammals as well. Do we have those? We absolutely do. We have found a ton of mammal jaws from different sites in the Judith. This is again Jack's bone bed. This one is not fully prepared, but it's all intact. Looks like it has most, if not all, of the teeth. This was found by our summer intern, and he set it aside for Deanna or I once we got back from the field. This specimen is ideal for doing on a stream. So this I have lined up for streaming preparation in Badlands Dinosaur Museum. So you can look for some mammal stuff in the future if you're part of the Twitch stream right now.
I showed a picture of that during the talk. That's one of the it's quite a big one for a mammal from the Campanian.
We've been getting a lot like that though. Like in recent years, we've been getting a lot of mammal jaws.
We have found a few mammal jaws in recent years. Finding them with teeth in is still not as common, but we have a few. We've got that one and the other one in the other room are really good ones, and then we have a few sections with teeth in that are still very good for research. And they don't take up much space in collections either,
No.
which is always nice.
And I'll reiterate how careful we are with these jackets, because that wasn't found in the field. That was discovered in a jacket that we already took back. It was inside the rock that we left just to, make the bone that's already in the jacket safe. We don't want to dig all the rock out. Garrett was digging through the rock, and there was a mammal jaw. It's another reason why you do most of this stuff under a microscope, at least to be aware of all the little particles, because there's only a little bit sticking out when he found it, and thankfully he was using a microscope.
Yeah, and we keep all these little bits of bone, these little fossils that are found in association with the bigger fossils that we collect. So they're in little bags with the fossil they're associated with. Oh, what's this?
What do you think?
You've been going through my favorite things.
Yep.
Which side is this? Oh, this is from the main. Yeah, this is a collection of fossil poops from Jack's bone bed. So a lot of those bags that we're opening have turtles and crocodiles, maybe a few small dinosaurs, because they're a bit more solid. But these are little poops, and they vary. This is just a chunk of one, but poops are actually interesting that you can look inside of them, maybe find something that the animal ate. They also actually store different chemical signatures of the environment quite well. So even a fragment of one can be used by a particular kind of researcher. So they're just another part of the associated data specimens that we have. This one's quite good actually. I think I left this one broken because it shows some little pieces inside. See those little black and orangey bits? There's parts in this. I don't know whether they're bone, bits of plant. I haven't looked, but I left this one broken because it shows that.
In response to another question, do we have any postcranial material from mammals? I don't.
Yeah. We have some postcranial material from mammals, but
In the Cretaceous, that is.
yeah,
Cretaceous
we've got
mammals.
things from the microcytes.
Yeah.
We have some limb bones, we have toe bones. They're very small, and
If anybody knows, here's some tiny bones. If any of those are mammal, let us know.
Right, it's very likely we probably have a lot of mammal postcrania. It's just
Yeah,
We
we
find
have
small
so many
bones.
microbags to open, and it's like so many small bone. What is that? Got to go to the next
It's
one.
like, is it a
and
frog? Is it a
build
mammal?
up.
Just it goes with the small
And
bones.
we do have researchers visit. We had many come from France who were very interested in the little frog and amphibian stuff we had. Amphibian people come, and it's the coolest thing ever sometimes, they think. But to us, it's a little bone. That's why it's important to establish ourselves as a repository. It's not just for us. It's for researchers around the world to visit, just like Filippo did with Had Enough, and study what we have, because we can't be an expert on everything.
yeah, the little salamander jaw I showed in the talk is actually really complete. It's quite a big salamander too. That jaw is over an inch long, so it's a decent sized salamander. It's one of the larger salamanders you get around here. And it's quite interesting because it's quite stretched out as well, so there's not that many of that particular kind of salamander that are as well preserved, so that'll be one that Steve can have a go at under the microscope, and you can see. It's a whole new world, a different level, all these little tiny things, and this site is so full of, Jack's bone bed is so full of these small, very well preserved specimens, as well as the big well preserved specimens. It's quite astonishing. We have bags and bags of sediment to sort through, to sieve, but not in the winter. It's an outdoors job. Any other questions? Requests?
Someone's asked, do we ever find fossil parasites in fossil poops?
I don't know what the answer to that question is. I know that people do look at coprolites and they look for deposit feeders, so they look for different insects that might bore into old poop to eat, like dung beetles and stuff like that, or alternatively, things that burrow their way out. You know, if something's laid eggs on them. I used to find some in England that had little bore marks in them like that. I don't recall if we have any here though. I don't recall if we have any coprolites that have borings in them. I don't think I've come across that. They're not, coprolites aren't that common in the Judith where we work.
It's not big ones.
Some
Not
parts of the
They're usually
Help
pretty
Group, you
small.
get them loads and loads of them, but in the Judith I haven't seen as many. It tends to be something site by site. Sometimes you just get a site covered in them. But,
And we've got another question. Do we do any looking for microfossils? Denver.
yeah, I mean, we look for microfossils. We do surface collecting where we get on our hands and knees and we collect all the tiny things. And we have sites. You know, these are some of our sites that we've been collecting for many years. This is uplag, so there's all sorts of tiny things. That's that toe of the Oryctodromine that I showed in the talk. These are not super tiny fossils. This is actually a fairly unusual area because there aren't really any true microsites. Most of the fossils tend to be sort of a centimeter and bigger. Uplag, this one actually is one of the few that do have a good microfauna. So we can actually sieve that in the future if we want to. But then in other areas that we work, there are actually some really good microsites. And Liz's background is partly in microsite processing. So we have set up a sieving station behind the garage here at the museum, and we're going to be processing a lot of the sediment that we have from Jack's bone bed, because that one's super rich. But it's a quite labor-intensive thing. Questions? Requests?
You mentioned that the site might be so fossil dense because it's a Lagerstätten. What was that?
Well, Lagerstätten come in two forms. They have concentrat, and it's a German word originally, and I'm not very good at German. I only did it for a year.
These ones are cognates. It's okay.
And so you get concentrat Lagerstätten, which is a concentration of lots of fossils. Then you have a conservat Lagerstätten, which is where the fossils are exceptionally well preserved. And of course, those conservat ones are the most famous ones, where you get incredible preservation of like feathers or soft tissues. Or, the Burgess shale is a conservat Lagerstätten. It's also a concentrat as well. You get loads of animals that are well preserved. This one, we do get skin, so there's an argument that you could say that there is an element of the conservat element there, but it's just the sheer concentration of rare taxa at this site. It's like who decides whether something is a Lagerstätten or not, but it's an exceptional site. It's the best bone bed I've ever dug, which I suppose says something maybe. Liz has dug a few bone beds.
Yeah, but they've mostly been hadrosaur bone beds. This is the first multi-taxic. Like, the diversity, like, maybe half the bones are hadrosaur, and then we have everything else in the world. This is definitely the nicest site I've ever worked, and I've said that before on other sites, and this topped them all. And I don't see how we could beat this site. This is incredible.
Right.
Yeah, we talk a lot about Jack's bone bed in
Because
this
it's like,
particular
why
one,
wouldn't
but
we?
it's because I think, partly because Deanna's been prepping all this fragile stuff, and it's given us that diversity, and it also gives us the finish. Like, you have a lot of these bones looking really nice. Like, we see them in the field, but they're not fully clean or anything, so we get excited about it, but you've still got to wait for it to be clean.
They do preserve really nicely, though. They abrade really nice. They're not often super spongy on the outside. They've got a great finish.
Yeah. The rock breaks clean around the bone, and I
The
think
sandstone helps.
one of the reasons you can be so quick in preparing these, and I don't mean that in a bad way, I mean in a good way, is because if you know what you're doing, you can actually prepare this stuff quite straightforwardly and well. Like, and you guys do know what you're doing. Obviously, you support the bone well. It's good bone. It's easy to see. It's a different color from the rock.
It's true.
there's a lot of aspects to it that make it just a wonderful site to work.
Any more questions?
Well, there's one about how does poop fossilize in the first place, so we're getting to diagenesis.
Poop fossilizes usually are carnivores. Herbivore poop is more sloppy and falls apart more easily. Carnivores has a lot of phosphate in it because of bone material and various other chemicals that allow it to preserve more easily. So most of the little poops that you see, especially the well-formed ones, will be from carnivores.
Go to a zoo and watch the hippos swim around for long enough, and you'll understand herbivore poop issues.
Yeah, it's a lot of plant
Ceratops
material
closest.
and it breaks down. Yeah.
I come from a dairy area. They're different from beef areas. You watch your step.
Well, as we start to wrap up, I want to make sure my Twitch crowd knows that, thanks for being here. It means a lot. I love you all buying magnets and shirts. That's great.
Yeah.
And for supporting our science, letting Deanna work on some of those really cool fossils we showed you earlier. I'll raid you guys into another science-y channel before we wrap up. I'm just going to go click the button when we decide it's over. But again, thanks for being here. I've been monitoring Twitch. I haven't seen the traffic on Facebook or YouTube.
Yeah.
Anything
But
to add
it's
on
been
that?
fun.
Yeah.
Thanks for joining us.
Let me set up that.
And I hope you all really enjoyed it.
Braid
I think
there.
the production this year has been really great. Like we've got IT guys, you haven't seen them because they're behind the cameras, but they've been running the cameras, and we've got new cameras and microphones, and it's all worked so smoothly and so well.
All right, we're ready to do the raid. So Twitch crew, we'll see you later. Thanks for being here. Heading to the Jang, a building and modeling channel.
Cool. All right. Well, is that good night?
Yeah, I think
so.
so. Thanks very much, everyone, for joining us,
Thank
and
you.
keep your eye open for any more streams that we might do in the future. And,
Follow my Tumblr.
If you're in Dickinson, come to the open house tomorrow, 3 till 6, and we'll show you some more of these fossils. Just enjoy some cocoa.